Night folds over the planet like a patient tide, and a thin filament of light writes itself across the high air. It is faint at first, almost doubt, a rumor in the dark. Then it hardens into a line, the way a whispered thought hardens into fear when the listener realizes the voice is real. It is not a meteor from the familiar reservoirs that cradle the solar system. It is a messenger from the silence between suns, a shard that has learned the grammar of exile. The sky has always offered stories, but some arrivals do not belong to any of the old sentences, and that is why the eyes of a species rise. Across observatories and antennas and quiet rooftops, where patient amateurs nurse coffee and wait out the cold, the instruments begin to hum. A slow orbital ballet plays beneath this moment, the Earth turning, the Moon keeping her steady pace, the planets following their obedient curves. Yet here moves a line that refuses obedience. No ellipse claims it. No algebra of return waits for it. The visitor crosses the stage and does not bow. Gravity reaches, and the visitor does not accept. In the softness of the night air, in the leaf noise of sleeping towns, this refusal is a drama as loud as thunder. The light is not bright in absolute terms. Photons skim from a surface darkened by ages in cosmic winter, by carbon crusts and dust welded by time. The shine is the small work of a star that never knew this traveller, now painting it in borrowed fire. Somewhere in the thin veneer of coma and gas, the visitor breathes, perhaps with a faint sigh of sublimation. Hydrogen and heavy molecules lift and scatter, a veil no thicker than thought. To human eyes, the veil is almost nothing. To instruments, it is the start of a biography. Every planet is a compromise with danger. The air that warms lungs can also carry shock waves. The oceans that cradle life can lift tsunamis. The rock that lifts mountains remembers its molten youth. Still, the world has felt for a long time that it lives under a kind of shelter. Telescopes survey the asteroids that share this Sunday. Catalogues grow, simulations run, percentages comfort. Daylight cities build their urgencies out of normal weather and normal economics, and at night children sleep while galaxies wheel through a window they cannot see. The visitor peels that comfort back by an inch and reveals how thin it always was. Between stars, shards and snowballs wander without permission. Sometimes they pass, and sometimes they aim. The object slides inward with a speed that feels like a sentence. Space is large, but speed is a way of making it small. Behind the visitor lies a distance like a scripture written in light years, possibly the wake of a shattered nursery around some long, unfamiliar star. Ahead of it lies the compressed geometry of a close pass. A brief conversation with the sun that will bend its path but not its nature. The path is hyperbolic, the pure signature of a thing that belongs to elsewhere. Einstein's equations are not offended, but something in the human heart is. There is security in circles and ovals. There is uncertainty in a curve that never closes. Hearts alone do not run observatories. Silicon does, and glass, and the discipline of nights counted by signal-to-noise ratios, and calibrations that smell like solvents and diligence. Early detections link into a track, and a track implies origin. The origin is not an address but a negation. Not from here, not from our cloud, not from the lazy paths of dormant comets that only pretend to be strangers. This is genuine awareness, and it carries with it a change in scale. A local threat is a bullet. A visitor from the interstellar dark is a story about the universe itself, even when the probability of harm is small. It is a reminder that the solar system is not an island with polite tides, but a harbour with a missing wall. The planet breathes on, unaware, in any ordinary sense. Trains keep schedules, servers hum under climate control, and a hospital elevator opens to reveal a nurse who has counted too many night shifts. Yet even here the visitor changes the air. It alters the stories people tell about safety. It suggests that defense is not a shield but a ritual, an arrangement of time and watchfulness and consent, something like a curtain that must be kept in motion to remain real. A curtain is not armor, it is a practice. The practice must be old enough to be trusted, and young enough to learn from the very things it fears. Clouds move over some telescopes and leave others clear. A ratio of clear to cloud becomes an implicit dice roll with the future. Each passing minute is a chance to refine a light curve, to capture a spectral fingerprint, to subtract the noise of a restless atmosphere. The visitor has no sympathy for weather. It has no sympathy for funding cycles or national boundaries, or the tiredness of humans who rise for school the next morning. It simply moves. That is its purity. That is also the source of the ache that creeps into the control rooms, into the text messages that hop between continents, into the database fields that begin to fill with numbers that will be argued over, loved, doubted, revised. The star field behind the object is a frozen choir. Each point of light tells of fusion and time, of gravity sculpting fire into spheres. The visitor glides in front of this patient choir, a dark note that refuses to sustain. No one owns it, yet everyone owns the feeling that climbs the spine when the mind forms a picture of its path. The picture is simple. It came from out there. It will pass through here. It will vanish back to out there. The simplicity is what makes it unbearable. There is no reason to expect only one. There is every reason to expect another. The air over deserts and mountaintops grows thin and cold. In the thinness, light sharpens. In the sharpness, the visitor yields more than brightness. It yields rhythm. Minute to minute, the slight spin or tumble can modulate the light, pulse by pulse, like a heartbeat buried in rock. The heartbeat is not a promise. It is an invitation. It invites minds to ask where in the unclaimed lanes of the galaxy this shard was shaped, what collisions roughed its geometry, what frost etched its shadows. It invites the old questions too, the ones that sound like prayers. How often does this happen? How fragile are we? How do we keep watch without losing the part of ourselves that looks up in wonder rather than crouching in fear? Far below, water moves in rivers and cables move integers in tidy packets. And a few floors above the ground a teacher stands before an illuminated map of the sky. The teacher does not mention the visitor by its catalogue number. The teacher says something simpler. A rock from another star is passing by tonight. Eyes widen. The room lifts with the thought that children are contemporary with such a thing. They will remember that feeling, not the uncertainties yet to be written, not the probability distributions, not the dust models. They will remember that the sky can import history. The planet hangs in blackness, an orb stitched by faint auroral curtains near its poles. The word curtain becomes an emblem. It suggests softness, but also a boundary that can be drawn where none naturally exists. The species may never wall the sky. It can, however, hang a curtain of vigilance across it, a fabric woven from early eyes, early warnings, early rehearsals of impossible choices. The curtain cannot halt an interstellar traveler by itself. It can only make sure the moment of knowledge arrives before the moment of consequence. That difference is civilization. That difference is the kind of quiet courage that nobody sees until it fails. Tonight, it does not fail. The object is seen. It is measured. It is named by a process that turns raw astonishment into the seriousness of record-keeping. A streak across the sensor. A handful of magnitude measurements pinned to time, a whisper that becomes a brief everywhere, a hush, then a swelling chorus of analysis, all of it unfolding under a sky that has, for billions of years, been both roof and ocean. The visitor crosses that ocean with no regard for small creatures on a small shore. They watch anyway. Watching is what made them human, and now it is what may keep them here. The line of light fades toward the horizon. Dawn, somewhere, begins to blue the air. The story has barely begun, but already the shape of it is visible, like a coastline in fog. A shard from between stars has come to write a new sentence in the long book of the solar system. The ink is light. The pen is motion. The reader is a world that has decided to stay awake. The name arrived first as coordinates and magnitudes, a small parade of numbers marching across a console in the Chilean night. On a ridge above Rio Hurtado, an automated wide-field telescope in the Atlas network swept its rectangle of sky and found a point that did not belong to yesterday. The station code W68 fixed the place on Earth. The time stamp to the discovery was the 1st of July 2025, close enough to winter in the southern hemisphere for breath to ghost in the air of anyone tending the hardware. The object moved against the star field with a steadiness that suggested intention. Pipelines caught it, flagged it, and pushed it toward the waiting minds who keep the midnight watch for things that refuse to circle back. Reuters. Zai. Atlas was built for closer dangers. Its name carries a promise that borders on myth, a last alert for stones that choose Earth as a target. Yet this detection carried a different flavor. The measured positions fit a trajectory that did not like ellipses. Preliminary orbit solutions reached for parabolic and slipped into hyperbolic. At first it felt like a dare from the data. Noise can pretend to be speed. Imperfect subtractions can pretend to be escape. Then additional exposures confirmed that the motion was both real and impertinent to the sun's gravity. The Minor Planet Center opened a gate for urgent confirmation while telescopes on 3 continents pivoted to join the first look. Reuters. Zai. Before the name 3, I settled like frost on the record. A quiet archaeology began. Survey archives were probed for earlier frames, where the same point might be hiding within crowded starfields. The Zwicky transient facility yielded recovery dots from June that tightened the arc and stripped ambiguity from the mathematics. Atlas itself had recorded whispers in late June and even in May, veiled by the dense choir of stars near the galactic center. Each rediscovered speck narrowed the fan of possible futures until only a hyperbola remained. The exercise turned a night's curiosity into a certainty that the visitor came from beyond the sun's dominion. Wikipedia. Not every new thing in the sky wears a comet's veil at first sight. The earliest images showed a point with no obvious softness. Some voices called it an asteroid, a shard that resists sublimation even this close to a new Sunday. On July 2, larger mirrors found a hint of fuzz, a marginal coma with a suggestion of a tail only a few arcseconds long. That faint breath tipped the balance. The object was granted a cometary designation alongside the interstellar marker. It acquired 2 names, like a person with a given name and a title. C divided by 2025, N1 and 3. I. A bureaucratic poetry that says origin and nature in a few characters. Wikipedia. Discovery is never one set of hands. It is a relay. Atlas detected. The MPC coordinated. Professional observatories lined up time on instruments tuned for faint smudges that move. Amateurs armed with disciplined workflows and fast optics pulled their weight, adding positions that improved the orbit model overnight. A community that often chases near-Earth objects in defense of a fragile planet now traced an emissary from another nursery. The language did not change much. Astrometry, photometry, signal to noise. Yet the emotional temperature shifted. The sky had sent a third interstellar traveler into the ledger. The catalogue number was dry. The feeling was not. Reuters. Zai. In Hawaii, on Mauna Kea's summit, and on Haleakala's shoulder, time allocation committees moved quickly. In Chile, the Andes lent their black air to longer exposures. From orbit, Hubble and other spacecraft sharpened the view beyond what the atmosphere would permit. The comet was small on every sensor, but small is enough when the geometry is kind. Slight color gradients appeared, indices that carry tales of dust grain sizes and gas species. Later images would turn that palette more vivid, but even the first spectral hints sketched a chemistry that felt more cousin than stranger. Carbon, oxygen, water in the act of parting from ice. Life science. Zai. The direction of arrival was a note worth underlining. The radiant laid close to Sagittarius, that dense highway near the Milky Way's center where background stars can trick the eye and the algorithm. Predictions had leaned toward the solar apex as a likely source for many interstellar passers-by, the direction the sun is heading through its local neighborhood. This one came from another quarter. It complicated the mental map and hinted that the galaxy's traffic patterns might be more democratic than theory had suggested. The sky loves to gently embarrass expectations. Wikipedia. Confirmation brought a second wave of work. Photometric monitoring began to carve a light curve that could reveal rotation. If the nucleus tumbled, the brightness would ebb and swell with a cadence that clocks the spin and whispers about shape. Astrometric refinement kept peeling uncertainty from the orbit until future positions could be predicted to arc-second precision. The cadence of observations settled into a pulse that matched the comet's pace across constellations. A few nights went missing to weather, many did not. The network planet proved that it could hold a moving point in focus across changing skies. There was a question that haunted the early weeks. How big? The coma hides the core. Models must reach through the haze with guesses about albedo and activity to infer a diameter. Estimates ranged widely at first. Some headlines shouted a mountain, some whispered a hill. The professionals hedged and let the sun do the excavation. As heating increased, gas production would betray surface area, and surface area would corner size. With each day of approach, the fit improved. The comet resolved into something neither trivial nor apocalyptic. Large enough to educate, small enough to pass without writing itself into the fossil layer of a biosphere. Reuters. Distance to Earth mattered less than speed and geometry, yet it comforted many to know the missed distance. The numbers gave breathing room measured in hundreds of millions of kilometers. The path would come closest to the sun in late October. Earth would keep a respectful separation even in December. The visitor was not a hazard in the ordinary sense that mobilizes evacuation plans and press conferences. It was a scientific event of the first order and a cultural moment that could teach the thrill of finding a rock from another star with instruments designed to protect a single world. Reuters. The confirmation also unlocked a subtle change in the observing strategy. Near-Earth trackers usually prioritize discovery and rapid orbit determination. Interstellar comets invite patience. Their stories are written in composition and texture as much as in path. Teams scheduled spectroscopy across the optical and infrared to listen for water, carbon monoxide, carbon dioxide, and the more fragile species that tell of temperature histories and cosmic ray gardening. Space telescopes, free of atmospheric absorption, promised clean lines in places where ground-based instruments must fight the sky. The first detections of water and other volatiles were greeted like old friends arriving at a frontier town. Sky at Night magazine. In the first month, a visual personality emerged. Some images showed hints of jets, narrow fountains of gas, dragging dust outward from vents that open as sunlight drills into shadowed pores. These structures rotate with the nucleus and carve spiral traces into the near-comet environment. Morphology is biography in motion. It tells of layers laid down in another system, of fractures that might have opened in a collision long before any eye on Earth was tuned to witness the result. Hubble's sharp vision teased out changes in color that might track the awakening of different ices as the heat budget climbed. Life science. Every discovery rewrites a procedure. Atlas added new filters to its triage for objects with suspicious speeds and arcs that point in from unusual directions. The MPC refined messaging templates so that interstellar candidates could be pushed to the community with maximum clarity and minimum delay. Larger facilities carved blocks of target of opportunity, time reserves into their calendars for future visitors. The act of naming 3I carried an instruction to prepare for 4I, not out of doom but out of respect for a sky that keeps producing surprises. Reuters. Public curiosity met the data stream in real time. Museum domes and science centers folded the comet into programs that let crowds trace its progress night by night. Viewers learned to read charts where a point crawls across plotted stars, learned to trust that even a faint smear in the eyepiece is a conversation with regions far outside the sun's family. A city in India scheduled a day of talks and telescope time to honor the perihelion passage. The event's posters used the word interstellar, with a pride usually reserved for national sports or festivals. Discovery changed the air over places far from observatories. The Times of India. The moment the designation became official was quiet inside the rooms that had done the work. Someone pressed save on an orbit solution. Someone posted a short circular to the network. Someone stepped outside to look up, not to see the comet with naked eyes, but to feel the alignment between a human life and a fragment of the galaxy's longer story. Discovery is a technical act and also a confession of attention. The system had been built to keep a planet safe. On that night, it did something larger. It proved that watchfulness can welcome, as well as warn, that instruments designed for defense can also open a door to wonder that stretches beyond one star's light. Reuters, ZAE. The quiet habits of celestial mechanics prefer closure. Ellipses, cradle planets, comets return on elongated ovals. Even parabolas carry the politeness of a theoretical boundary where energy balances exactly at zero. Then the new orbit solution arrived and printed a single letter that rearranged the room. Eccentricity greater than 1. The curve did not fold back on itself. The line refused to become a loop. By the standard grammar of the solar system, a body that will never come home is not a misprint. It is a new subject in the sentence, unbound and carrying positive energy. Like a passport, stamped by another Sunday, numbers made the affront precise. Specific orbital energy rose above the calm of zero, signaling surplus motion that the sun could not collect. Hyperbolic excess velocity settled into a value that, while evolving with improved data, remained stubbornly positive. At large distances from the sun, the object would still be moving, not drifting toward a halt where capture might whisper a compromise. Gravity, so practiced at rounding trajectories into years, could only bend this one by a finite angle and let it pass. Nothing stayed broken in the laws. What cracked was the expectation that the solar system sets the terms for every visitor that dares its light. The shock deepened under another lens. Inward speed negotiated with the escape velocity at 1 astronomical unit, a fierce number that usually humbles incoming wanderers. Near Earth's orbit, a stone must race faster than 40 kilometers per second to slip the sun's grip. This traveler committed to its sprint long before any telescope named it. Acceleration near perihelion would be dramatic, but that drama was not freedom's source. Freedom lived in the energy budget far from the sun, a quiet assurance that no matter how the star flared and pulled, there would be speed left over after the conversation. The equations that steer routine defense work became less comforting. Surveys are tuned to catch nearby families of rock that move slowly enough to be seen in multiple exposures before they blur into the seeing. Algorithms predict context from decades of orbits that button neatly into bound solutions. A body that arrives already impatient with gravity presents a different challenge. It crosses fields quickly, fades away from the cadence of standard pipelines, and demands rapid coordination across longitudes so that one night's track can become a reliable arc. Instruments built to keep a cradle safe now stared at something that never intended to touch the cradle at all. The contradiction was useful. It tested the flexibility of a system designed to be calm under stress. The path told on its origin in a way that pricked the skin of old ideas. Local interstellar space has its own weather, a drift that astronomers describe against the local standard of rest. Many had expected future interstellar passers to arrive preferentially from the solar apex, the direction of the sun's own motion through its neighborhood. This inbound direction chose a less tidy story. The radiant suggested a traffic pattern that is less a wind and more a cloud of histories, fragment streams launched from many nurseries by many sets of giant planets that had cleared their throats and flung their leftovers outward. What had been a neat picture of flow became a chorus of trajectories, some head-on, some sweeping from the side, some sneaking up from the blind quarter near the sun's glare. Classification strained at the margin between asteroid and comet. Early images lacked a dramatic tail. Later frames revealed a breath of coma and hints of jets, but activity remained a delicate skin rather than a banner. The surprise was not that ice could wake when warmed. The surprise was how efficiently even a faint exhalation could tug at the orbit solution. Non-gravitational accelerations, the quiet push of outgassing, began to nudge the predicted ephemerides. The math absorbed the change, but strategy felt the tremor. If a visitor from deep cold can modify its own steering with a few grams of escaping molecules each second, then timelines for precise targeting, for follow-up spectroscopy, and for any thought experiment about intervention must include room for that whispering thrust. There was a moral hidden in the photometry. Brightness did not climb as fast as some models would have wagered. Surface textures and volatile inventories, baked in another system and aged in interstellar frost, likely differed from the catalogue of familiar comets. Grain sizes in the dust, the color of scattered light, the ratio of water to carbon monoxide and carbon dioxide, all sketched a personality that family textbooks might not anticipate. The shock was not an exotic molecule. It was the ordinariness of water and carbon appearing in unfamiliar proportions, written into an origin story older than the solar system. Chemistry that felt like cousinhood still dared interpretive humility, since a single body is a poor ambassador for an entire galaxy of foundries. Dynamics added a subtle ache. In analyses that compare orbits to Jupiter's influence, a dimensionless number often separates comets born in the distant Oort cloud from interlopers that bear signatures of planetary scattering. The new object kept that index meaningless. Tisserand parameters assume a coherent family whose major sculptor is a single planet. A stone from the far outside does not speak that dialect. In a discipline that loves categorization, the box labeled "not applicable" can feel like a little thunderclap. It reminds everyone that frameworks are maps, not the terrain. Population estimates felt the jolt. 2 previous interstellar visitors had already forced revisions to the inferred density of free-floating small bodies in the neighborhood between stars. A third messenger did not simply confirm the upward correction. It pushed the error bars inward and hinted that ejections from planetary nurseries might be more common than conservative models allow. Every young system that births giant planets likely spares no mercy for its leftover pebbles and mountains. The long game of gravitational billiards sends a fraction into orphanhood. When a third wanderer arrives within a human generation of surveys, the inference sharpens. The dark between stars is not clean. It is full of slow storms of debris that only now begin to show themselves in samples that an entire species can watch with shared attention. Warning times stared back with a cool face. For a typical near-Earth asteroid on an Earth-crossing path, years of tracking may accumulate before any serious risk geometry forms. For a high-speed interstellar body, the clock starts late and runs fast. The practical interval between discovery at a faint magnitude and the moment of closest approach can compress into a season. The gently terrifying truth is simple. A stone that never belonged here does not grant long conversations. It sets the terms. Any future scenario that imagines deflection must face that arithmetic, not as a theatrical panic, but as a boundary condition that shapes engineering. Slow technology is wisdom. Fast detection is mercy. Even the light curve participated in the defiance. Rotation signatures appeared cautious, perhaps stabilized by a squat shape, or perhaps confused by patchy activity that turned on and off as sunlight walked across the nucleus. Interpreting the rhythm required assumptions that refused to sit still. The surprise grew philosophical. There are objects whose stories become clearer the longer one watches. This traveler improved in increments that never quite erased ambiguity. Precision increased, yes, but interpretation stayed attenuated by distance, velocity, and the partial truths of reflected light. The result felt like meeting a stranger on a fast train platform. Faces can be memorized. Hearts cannot be read in that wind. Fear stooped nearby and then stood aside. The missed distance gave comfort in kilometers. The shock that remained was intellectual and procedural. A defense architecture designed to be comprehensive within the solar system must accept that comprehensive is a moving target. New surveys, sensitive to warm objects in the infrared, will be needed to guard the sunward blind spot where many approaches hide. Coordination between ground and space must rehearse a new tempo. The posture shifts from watching a fenced field to watching a coastline that receives visitors from an ocean with no charts. No law faltered in the sky. Newton and Einstein remained serene. The surprise lived in human habits, in the way planning prefers repetition, in the way comfort grows around familiar distributions of speed and inclination. An unbound orbit is not a rebellion. It is a reminder that gravity is a negotiation, not a dictatorship. The sun will bend what it can. Some stones will nod and circle. Some will bow once and keep walking. To witness that etiquette play out at scale is to feel both smaller and better oriented. The solar system turns out to be a room with most of its walls missing. The proper response is not dread. It is clarity. The console lights dimmed only because nights end, not because astonishment does. The equations accommodated the visitor with grace, but ornamented their margins with cautionary notes. Timelines must shorten. Sensitivities must rise. Assumptions about approach directions must widen. Chemical expectations must loosen. The shock did its necessary work. It woke a field that already prided itself on vigilance and asked it to expand its imagination. In the quiet that follows an update to a database, the meaning crystallized. A curve that never closes has opened a new chapter in how a species counts its neighbors, measures its risks, and understands what kind of road the solar system really is. Light became the archivist. Photons scattered off a rough nucleus and through a gossamer coma, then fell into glass and silicon where dispersion carved them into colors the eye alone cannot pass. A low-resolution spectrum spread like a shallow rainbow, and in that gentle fan the first signatures rose. Near 388 nanometers, a violet band hinted at CN freed by sunlight from more fragile parents. Farther redward, faint molecular bands of C2 murmured through the noise, their ladders a memory of carbon chains braided in deep cold. In the infrared, the slope lifted as thermal grains warmed, and spectral windows around 3 microns and 4 to 5 microns invited water and carbon species to speak. Every line and shoulder offered temperature and chemistry woven together, the simple story of ice waking under a young sun that was not its own. Brightness learned to breathe. Night after night, the light curve picked up a rhythm, not a metronome but a living cadence shaped by rotation and activity. Small variations hinted at a nucleus, elongated enough to flash more area toward the observer in a slow turn, then offer less, then more again. The amplitudes were modest, which suggested either a compact shape or a surface where jets temporarily level the brightness by lifting dust in arcs that blur the geometry. When the cadence jittered, analysts suspected a tumbling state, a rotation not about a single stable axis, but in a precession that remembered past torques from asymmetric outgassing. The fit to a single period could be made for a week, then eroded, then reasserted. The comet kept its private hesitations, and the light curve translated those hesitations into numbers that breathed like an animal asleep. Spectral lines were less coy. In green light, the forbidden line of atomic oxygen at 557.7 nanometers rose from the background, a quiet echo of water photo-dissociated by sunlight in a coma, so sparse it could be mistaken for emptiness. Oxygen's other whispers around 630 nanometers joined when the sky cooperated. Sodium sometimes announced itself with the golden D lines near 589 nanometers, a brief flare when dust grains released trapped atoms. In the infrared, strong telltale features near 7 to 3.1 microns betrayed water vapor, while bands at 4.2, 6, and 4.7 microns negotiated the balance between carbon dioxide and carbon monoxide. The ratios were not freakish, simply personal, a chemistry that belonged to a birthplace sculpted by a different star's adolescence, then edited by eons in interstellar night, where cosmic rays gnawed at bonds and layered organics into skins the color of old tea. Dust carried its own language, older than gas. Imaging through broadband filters produced a warm reflectance slope, a redness that matched the taste of complex organics baked into the surface and powdered by eruptions. Polarimetry made the grains speak about size and shape. As phase angle grew, the coma's polarization climbed, sketching a distribution of submicron to micron particles with rough facets rather than perfect spheres. The afrometric, that workmanlike proxy for dust production, crept upward with each degree of solar heating, then stuttered when jets flickered off. Isophote maps showed a sunward cusp and a fan pushed anti-solar by radiation pressure. Syndenes and synchrones, those clean theoretical lines that trace grain sizes and release times, were overlaid like translucent nets on deeper images. Many grains obeyed, some did not, and the deviations told of vents that opened and closed as sunlight walked across the nucleus. The nucleus itself remained shrouded, yet its shadow could be weighed. Thermal models, assuming reasonable albedos and beaming parameters, converted mid-infrared brightness into effective size ranges. A small, dark object emerged, large enough to hold its gases, small enough to respond visibly to each shift in solar input. The beaming parameter flirted with values that indicated modest roughness and a porosity not uncommon among fragile aggregates. In optical light, the geometric albedo sat low, a charcoal tone shared by many comets. None of this was exotic. The biography lay in the combination and in the small offsets from expectations, like a familiar song played in a new key that changes how the melody feels without altering a single note. Activity traced a seasonal map in miniature. One hemisphere woke first, then handed the torch to another as the spin pole presented fresh terrain to the Sunday. Jets, sprayed in coils that unwound with rotation, then faded, then reappeared from nearby sources, implying a patchwork of volatiles and crust. Occasional brightenings unfolded over hours, not violent outbursts but modest surges, as a fissure widened or a pocket of more volatile ice reached critical depth. The coma did not thicken into theatrical glory. It remained delicate, which let starlight thread close to the nucleus and allowed careful subtraction to leave behind the faint skeleton of jet architecture. Non-gravitational forces nudged the ephemeris. In the standard formalism that uses 3 small parameters to capture radial, transverse, and normal accelerations from outgassing, the radial term grew measurable. This chematic thrust translated a few molecules per square centimeter per second into kilometers of positional drift over weeks, a gentle but insistent pressure that the orbit fitting absorbed with gratitude. The transverse term hinted at asymmetry, perhaps a set of vents placed off-center in a way that acted like a tiny thruster. Normal acceleration remained elusive, which quieted fantasies of extreme polar jets, but did not rule out more complex combinations. The result was both practical and intimate. Practical because predictions improved. Intimate because the comet's breath was visible in its walk. Gas production rates became the new clocks. Q of water rose with heliocentric distance shrinking, and with it the proxies for daughter species formed by sunlight and fragmentation. CO and CO2 played a cooler game, their yields not strictly locked to water's curve since their ices wake at different thresholds. Measured against classic comets, the ratios landed in the middle of the scatter cloud, neither a carbon monoxide powerhouse nor a desert. If there was a quiet surprise, it was the sobriety of the blend. Interstellar did not mean alien to the point of estrangement. It meant a different tuning of familiar chords. The coma's color shifted subtly as dust size distribution evolved. Early in approach, the red slope was strong, which often points to larger grains and richer organics. Closer in, as jets carved fresh fractures, the slope relaxed toward more neutral tones, possibly due to an influx of smaller particles that scatter light more evenly. In images processed to peel away the radial fall-off, spiral arcs appeared faintly, like fingerprints laid on fogged glass. Each arc corresponded to a past rotation, a calendar of eruptions written in dust. The intervals between spirals gave an independent check on the rotation period, a second opinion that matched the photometric rhythm within tolerable error. Attempts at radar were discussed with measured hope. The distance and the small nucleus made a direct echo unlikely, yet the discipline considered it for what it would mean to glimpse surface roughness and measure line-of-sight velocities with brutal honesty. The geometry did not cooperate. The idea remained as a note in a margin, a reminder that even devices tuned for near-Earth work can dream of reach. In the absence of radar, high-resolution optical and infrared images tried to substitute, teasing edges that refused to separate from the thin coma blur. The question of isotopes hovered like a promised land. Deuterium to hydrogen ratios, carbon and oxygen isotopic balances, the tiny numerical fingerprints that speak to the temperature and density fields of a long-vanished nursery, all beckoned. Reality trimmed the ambition. Lines were faint. Contamination by telluric absorption complicated ground observations. Space telescopes helped, but time was finite, and priorities had to balance precision against breadth. A few constraints emerged, conservative and careful, consistent with a world frozen at tens of Kelvin and stored in interstellar dark, long enough to build an armor of processed organics. Anything more specific would require a mission that could taste the gas at arm's length, a dream that now had a concrete target to justify the expense next time a stranger announced itself in time. As perihelion neared, asymmetry crept into every plot. The brightening curve steepened faster than the later fading, a common tale in comets where lingering heat and newly opened vents keep the coma alive, even as the solar input retreats. Tail length responded to radiation pressure with a bristle of streamers, each carrying a size class outward along a predictable arc. Close to the head, a sunward spine appeared on some nights, a fragile structure caused by largish grains that could coast briefly against radiation before falling back into antisolar fanfare. The visuals were modest and exquisite, a restrained script written on a backdrop of densely seeded stars. Through all of this, the core idea held steady. Reading a hyperbolic path is less a story about curves than about the messages riding within each photon. Spectra interrogate the chemistry of a birthplace hidden by time. Light curves take the pulse of a body under stress. Dust maps translate eruption patterns into a topology carved by ice and fracture. The details of equipment and calibration matter, yes, but the emotional truth is simpler. A species learned to turn faint light into biography. The biography was incomplete, but it had chapters now, enough to give the traveler a personality that could be spoken of without superstition. In the end, the data were placed together like panes of stained glass. Alone, each pane was a hint. Together, they shaped an image of a small world warmed into whispering, carrying familiar molecules in unusual proportions, rotating with a cautious pride, shedding grains that caught the sun like pollen. Nothing in that picture screamed of the impossible. Everything in it insisted that the galaxy keeps faith with certain recipes, then lets time and circumstance invent variations. The reading was careful. The reading was kind. And in that careful kindness, the object ceased to be a streak and became a life story written in exile and ice. Speed made the sky sting with brevity. A small world arrived wrapped in motion so lavish that every instrument had to argue with time before it could argue with physics. Exposures fought streaking, spectrographs fought faintness, schedulers fought the calendar, watching a window of darkness slide across continents like a tide no hand could stop. The visitor crossed constellations at a pace that turned careful campaigns into a sprint, and sprinting is not flattering to telescopes that prefer patience and repeatability. The faster the point moved, the more the facts condensed into fragments, and fragments are where secrets like to live. Tracking systems adjusted to non-sidereal rates that pushed their mounts to the margin. Guiding cameras stared at stars that insisted on becoming lines while the target was allowed to sit still. Each exposure length became a negotiation between signal and smear, between enough photons to draw chemistry out of darkness, and few enough seconds to keep the nucleus from dissolving into a dash. Photometry felt this as noise. Spectroscopy felt it as ragged lines that asked to be believed. Images that would have been routine for a lazy near-Earth asteroid demanded hand-tuned pipelines, new rejection filters, and a level of vigilance that turns night work into an athletic event. Solar elongation framed the cruelty. Approaching a bright star means the angle between target and sun shrinks. Telescopes fear that glare because air scatters light into fog, and even space telescopes respect the thermal and safety limits of pointing too near the furnace. As the angle tightened, ground observers worked into the cobalt of late twilight, hunting a smear barely above the glow. Infrared eyes in orbit could help, but they must keep their own safe margins. The result felt like watching a friend ghosts into a crowd and asking for one more wave before the image is swallowed by gold. Parallax offered a gift wrapped in difficulty. A fast mover changes apparent position when seen from different places on Earth during the same night, not by subtle arcseconds but by shifts that calibrate the scale of its proximity. To exploit that, observers on widely separated longitudes and latitudes need to coordinate exposure times down to minutes, sometimes seconds, while clouds, daylight, and fatigue conspire to disrupt the choreography. When the dance is clean, triangulation sharpens the orbit and prunes the family of possible futures. When the dance is clumsy, uncertainty lingers like fog on a river, and fog breeds superstition. The phase angle wrote its own script across the light. When a dusted coma is seen at larger phase, forward scattering can light it as though every grain were a lantern. When that angle changes quickly, interpretations wobble. Brightness can jump for geometric reasons and be mistaken for an outburst. Brightness can settle for equally geometric reasons and be read as exhaustion. Decoupling geometry from activity becomes a craft that lives on ratios, calibrated fields, and the willingness to distrust a dramatic evening until it repeats under a different sun angle. Speed compresses these angles into a handful of nights. A handful is not a sample. A handful is a taste. Thermal processes kept a clock of their own that did not match the observing schedule. Ice awakens with sunlight, but heat conducts inward with a lag that can keep gas flowing long after illumination moves on. A nucleus with complex porosity obeys time constants that stretch the difference between morning and afternoon on its own surface. These lags complicate any attempt to use brightness as a thermometer. The faster the orbit carries the body across changing solar input, the more asynchronous the response becomes, and the more one must rely on models that whisper about depth, conductivity, and poor geometry. Models love slow experiments. Speed makes models squint. The orbit solution, that beloved distillation of repeated measurements into a curve the mind can hold, depends cruelly on time span. Short arcs carry more degeneracy than long arcs, and degeneracy is a bureaucracy of possibilities. For a rapid visitor, the early arc might be days long before predictions are needed to schedule larger telescopes or space assets. Those predictions carry formal errors that look tidy in a covariance matrix and feel less tidy when a billion-dollar instrument must pivot to a point that may slide somewhere else before the shutter opens. Every new observation collapses the cloud of maybes, but the collapse must outrun the motion. Sometimes it does. Sometimes it sighs a beat too late. Non-gravitational forces further tighten the race. Gas drifting from vents imparts gentle accelerations that integrate into noticeable deviations from gravity-only trajectories. The parameters that capture this push can be fit, but they improve when the nucleus repeats its behavior across a span of heliocentric distances. A fast fly-through offers few baselines. If a jet wakes for a week and sleeps the next, the fitted thrust changes, and so does the forecast position. Defensive thinking must accept that such nudges can move the target by thousands of kilometers over weeks, which shrinks the comfort of any plan that fantasizes about rendezvous or even about a well-aimed look from a distant platform. Operational limits emerged in places the public rarely sees. Observatory domes have wind and humidity ceilings beyond which shutters stay closed. Instruments need calibration fields that are not always available in the same hour. The target is highest. Technicians must sleep to keep their hands steady on delicate mechanisms. Shipping cryogens on mountain roads takes time. Proposals require signatures. Scheduling software negotiates conflicts between supernovae, exoplanet transits, and a comet that will be gone soon. Speed compresses each negotiation into curt decisions, and curtness always risks error. Data pipelines discovered their own temporal physics. Raw frames descended from mountaintops and spacecraft, then slipped through cosmic ray removal, flat fielding, background subtraction, astrometric solutions, photometric zero points, and human eyes. Each step added minutes. Minutes matter when phase angle and elongation are running away. Automation helps, but automation takes months or years to write well, and software grown in quieter epochs must be taught to sprint without tripping over corner cases. The price of a misclassified streak is lost follow-up. The price of a delayed alert is a wasted clear night on the far side of the world that might have turned ambiguity into clarity. Communication channels also discovered physics disguised as etiquette. Words must be precise, cautious, and timely. Timeliness can bruise caution, precision can bruise speed, and bruised trust costs more than any single night of observations ever could. Teams learn to publish interim notices that carry uncertainty with dignity, to mark predictions as drafts without scaring readers who translate draft into danger, to build templates that let new information drop into familiar shapes that the community can parse fast. The clock pushed language toward a lyric of restraint. Planetary defense planners listened for numbers that translate to action thresholds: impact probability, Palermo scale, Torino color, close approach distance, time to encounter. A hyperbolic parser with a generous miss distance offered a tutorial without danger, but the arithmetic was transferable. For a hypothetical future body on a less kind line, Discovery at a modest magnitude could leave months or weeks before a hard decision about maneuvers and launches. Launch windows have their own celestial mechanics, with transfer energies that spiral out of feasibility as time drains away. Speed is not just a property of the target, it becomes a property of bureaucracies asked to act faster than their habits prefer, the psychology of teams bent under the ticking. Astronomers are not strangers to deadlines, but the ordinary deadline is administrative and human-made. This one rose from the geometry of the solar system itself. People grew quiet, then kind. They traded tasks at 3 a.m. across hemispheres to chase a target from dusk through midnight into dawn, then handed it over like a precious, fragile thing to another longitude. Jokes softened the effort. Coffee rehearsed its ancient role as a near-religious implement. At times the sky punished this devotion with a sheet of cloud exactly where the finder chart had been taped to a laptop. That is how speed humiliates plans. It sits on the other side of the glass and moves while rain talks to roofs. Public attention, once engaged, added a noise term that had to be managed. Excitement is an ally, but excitement craves drama and continuity, and fast objects provide the first and deny the second. When a timeline reads weeks instead of years, updates risk sounding repetitive to untrained ears, yet each update may carry a small revolution in the numbers. Translating that distinction for broad audiences without inflating risk became its own art. Clarity won trust. Overstatement wasted it. Even the humble matter of background stars conspired with motion to occlude. The crowded fields near the Milky Way transform small shifts into confusion. A point source that shares a pixel with a star bright enough to leak into the wings of the point spread function can drag the measurement off by a fraction that seems microscopic and becomes gigantically inconvenient when propagated through a week of forecasts. Deblending routines are good. They are not magic. The visitor did not wait for fields to thin. In the end, speed organized the hierarchy of what could be known. Composition could be sketched with modest confidence. Rotation could be argued, not declared. Dust dynamics could be traced in outline. Isotopes would remain a dream until a mission met a future traveler up close. The orbit would be excellent within limits set by gas thrust and geometry, then fade into delightful irrelevance as the body retreated into cold, where nobody bothers to predict the exact position of a grain of sand on the far side of the desert. All of this is fair. The universe owes completeness to no one. A lesson settled like dew once the busiest nights passed. Fast things do not only deny detail, they also reveal the exact shape of a capability. They show where flexibility is genuine and where it is a word in a grant proposal. They expose the distance between the speed of light and the speed of decision. They invite construction of systems that move information from sensor to understanding with less friction. And they reward the building of a culture that does not flinch when the sky asks for attention now. In that sense, velocity is a teacher. The curriculum is relentless. The tuition is paid in sleep, in retooled software, in schedules rewritten under red headlamps. The diploma is simple. A species learns to know more, sooner. Theories opened like windows at different heights, each view catching a separate angle of the same rushing world. The simplest imagined a nursery, much like the one that raised the planets here. A disk of gas and ice encircled a young star, and in that disk grew the common quarrels of small bodies. Collisions stitched pebbles into stones, stones into hills. Somewhere, a giant planet wandered, trading momentum with infant worlds until a scattering event lifted a fragment above the escape speed of its home. That was enough. One gravitational argument and a shard was set adrift into the wide neighborhood between suns. In this view, interstellar comets are not rare accidents. They are the intended litter of planetary architecture, the swept floor after giants move their furniture. Another line of thought placed blame on resonance. Migrating planets carve lanes of stability and instability, and objects trapped in the unstable lanes surf outward over many slow revolutions until a last nudge lifts them free. The timescale can be millions of years, a stately exile that ends with a modest positive energy and a path that tilts into the interstellar commons. No dramatic catapult required, only the patient arithmetic of gravity repeating itself until the tally tips. A more surgical story invoked a close passage by a neighboring star in a crowded birth cluster. Young suns are born in flocks. If two approach within a few hundred astronomical units, their spheres of influence overlap like ripples on a pond. Ice and dust at the outskirts of one system can be plucked into the other. Most will fall back. A fraction will miss both and slip into orphanhood. The odds of such exchanges are highest while clusters are young and dense. That timing leaves the ejected bodies with a long adulthood adrift before they stumble into another star's halo. If a traveler carries a chemistry that feels familiar, this scenario explains why. The factory is generic. The journey is what grants personality. Composition encouraged speculation about the birthplace temperature. Elevated carbon monoxide hints at formation beyond the water-snow line where sunlight is weak. A deficit in ultra-volatile species suggests later processing during the interstellar trek, where cosmic rays bake skins into crusts that seal deeper ices. If the outer shell becomes a resin of complex organics, sublimation only begins once fractures weather that armor. That would explain activity that wakes reluctantly, with jets localized to seams where stress finds a path. The nucleus might be a bundle of rubble with gentle tensile strength, a cathedral of voids and sintered dust whose porosity governs how heat travels inward and how gas escapes. Under that architecture, the rhythm of outgassing is less a uniform breath and more a set of flutes that take turns finding their voice. Spin invites narrative too. A slow rotation could be inherited from a gentle accretion history, then modified by countless tiny torques from uneven vents. Over many perihelion passages in another system, such torques could walk the spin state into a complex tumble. Interstellar night would then freeze that state for eons, preserving a kinetic fossil that wakes when a new star rises. If the present rotation appears calmer than expected, the explanation might be the damping power of internal friction in a loosely bound aggregate. Energy leaks into micro-movements along grain contacts, and tumbling settles toward a principal axis on timescales short compared to the voyage. The traveler arrives dignified, as if it had learned to carry itself through the long, dark. Shape whispers to dynamical history. Elongation suggests fragments torn from a larger parent by a collision that cut through ice and rock with a swift, uncaring blade. More spheroidal forms argue for accretionary snow, grains sticking in low gravity to build a rounded mass that never knew shattering. Observers read the light curve and guess at silhouettes as a poet guesses at a stranger's life from the way footsteps echo in a stairwell. Both might be right and both incomplete, since the surface carries crusts that smooth sharp edges and jets that drape temporary veils across corners and ridges. The distribution of incoming directions seeded the most cosmic of the speculations. If interstellar comets arrive from many angles with only a weak preference, then the galaxy's small body traffic is isotropic at the scale of the solar neighborhood. That implies prolific ejection everywhere, a continual rain of fragments that pass from system to system without allegiance. If instead a clustering appears along certain great circles, the pattern might reveal streams of common origin, debris fluxes still coherent, because their parent systems ejected them in coordinated epochs. Over centuries of survey work, those great circles would map the memory of planetary violence in distant nurseries. The sky would become a palimpsest of forgotten architectures, legible only to patient counting. Speculation also gathered around the question of survivability. An interstellar wanderer faces micrometeoroid sandblasting, sputtering by ultraviolet light, and the steady chiseling of cosmic rays. How much mass can such processes erode from a kilometer-scale body over hundreds of millions of years? Models argue that the outer centimeters, and perhaps decimeters, harden into a refractory shell that slows further loss. Migration through diffuse clouds might deposit or strip additional materials. Passage near a supernova could rewrite the chemistry in a breathless instant. The traveler we see today is therefore a palimpsest upon a palimpsest, a record layered by violence, drift, and healing. Some eyes turned the question inside out and asked about absence. If 3 interstellar visitors can be found within a generation of improved surveys, perhaps similar bodies visited many times in earlier centuries without being noticed. The night sky lacked wide, fast cameras then. The blind quarter near the sun remained unguarded, and faint comet slipping through twilight would have been stories told between sailors rather than entries in a catalogue. In that light, the present is not a sudden flowering of the galaxy. It is a late sharpening of human tools that finally catch what has been happening all along. Another conjecture lived where engineering and science shake hands. Could interstellar comets be used as natural probes of the interstellar medium? Dust tails capture and scatter plasma, flows in ways that depend on electric charge and grain size. If a future mission carried magnetometers and plasma analyzers into the coma of a visiting interstellar body, the instrument could listen to the ambient interstellar environment as filtered by dust born under another Sunday. The comet becomes a drifter's weather vane, tasting fields and particles that most spacecraft never sample. The idea pleases both poetry and pragmatism, turning a chance encounter into a science station that needs no launch to the space between stars. Einstein's patient geometry made its cameo in talk of long arcs. The path through the solar system bends mostly under Newton's care, but tiny corrections from general relativity creep into the timing of perihelion and the exact shape of the swing. The effect is too small to headline. Its meaning lies in an assurance that the same fabric that guides planets also guides a pebble from beyond, and that even speculative narratives rest on firm stone. The equations allow extravagant possibilities without needing to be theatrical. Questions about life hovered at the edge of the conversation, with both caution and awe. Panspermia finds a stage whenever frozen bodies move between systems. The sober position notes the cruelty of radiation over vast spans and the fragility of complex molecules in such conditions. Yet resilient organics do survive, and laboratory studies hint at tenacity in simple chemistry. If biological precursors can ride dust and ice across gulfs, then every star becomes part of a slow chemistry exchange. No claim demands that a traveler carries spores. It is enough to admit that the boundary between systems is not a wall for molecules, and that time grants permission for rare things to become common. Speculation stepped across the border into the future of defense, because understanding origin informs posture. If most interstellar bodies are small and fast, then the practical strategy is early awareness, not muscular interception. Infrared sentinels that read heat rather than reflected light can paint targets hiding near the sun's glare. Ground arrays with rapid cadence can lock trajectories before they pierce the twilight. Small craft staged in cislunar space could execute reconnaissance passes to refine size and composition. Exotic dreams such as laser ablation or ion beam shepherding belong to scenarios with years of warning, not weeks. The most defensible conjecture is cultural rather than technological. Build a habit of attention that outlasts administrations and fashions. Philosophy crept in last, as it often does, not to claim answers, but to frame the questions correctly. Theories about origin remind a watching species that it is part of a statistical universe, where singular events are the visible faces of vast populations. Speculations about chemistry place familiar elements in unfamiliar music, inviting humility rather than alienation. Guesses about frequency and direction translate into choices about which instruments to fund and which blind spots to close. The exercise is not merely academic. It is a rehearsal for living with a sky that will keep delivering strangeness in forms that are actually ordinary once counted. In the hush, after numbers are lined in columns, the best theory might be the one that leaves room for the next surprise. A fragment escapes a sun, hardens in night, crosses a gulf, and sheds grains that write pale letters across another star's light. Whether ejected by a giant's temper, a resonance's patience, or a cluster's crowded grace, it arrives bearing lessons wrapped in speed. Science peels those wrappings with instruments and equations. Imagination holds the pieces up to light and asks how they fit into a larger pattern. Between them lies a way of knowing that accepts mystery as a durable companion rather than an enemy to be crushed. In that companionship, conjecture becomes an honest lantern, bright enough to guide, dim enough not to blind. Instruments gathered like instruments in an orchestra pit, each tuned to a different frequency of truth. Wide-field cameras swept great rectangles of darkness with clockwork cadence, subtracting tonight's sky from last night's to reveal the stubborn pixels that had moved. Software learned to see the subtraction scars for what they were, and to set aside the ghosts that bright stars left behind. The survivors of this winnowing were tagged as candidates and pushed into queues that did not sleep. A curtain of vigilance is not a single piece of cloth. It is a weave of exposures, timestamps, and algorithms that trade notes all night. On volcano summits and desert ridges, survey telescopes dissolve the sky into a torrent of images. Panoramic eyes such as Pan-STARRS, ZTF, and the Catalina arrays sent a flood of detections into pipelines that teased motion out of noise. Farther south, a new giant prepared to open its eyelid for the first time, promising a nightly film rather than a series of stills. The gift it planned was not a single deep picture, but repetition so relentless that the faintest drifters could be followed frame to frame until a trail became an orbit. Cadence was the power, not just aperture. The curtain thickened with rhythm. Small sentinels took up the close guard. Atlas kept sweeping for fast movers that ambush from the near dark. Fly-eye-style optics explored the value of splitting a big vision into many narrow shards to cover more sky per heartbeat. Amateur networks filled gaps with nimble telescopes and disciplined methods, adding the kind of astrometry that pins an object to a precise place at an exact time. Their contribution was not quaint nostalgia. It was latency reduced to hours, not days, when weather or scheduling tied the hands of larger facilities. The fabric of watchfulness became resilient because its threads were varied. Infrared views from space-stitched shut the worst of the blind spots sunward. In reflected light, an object near the sun is washed in glare. In heat, the geometry is kinder. A warm rock glows against cold space even when the star is near the same line of sight. Space-based infrared telescopes, repurposed or built for the task, learn to measure brightness that is closer to size than albedo can fake. A small dark stone and a large bright one can look the same in visible light. In thermal bands, they confess their differences. That confession turns ambiguity into planning. Characterization rose as the second act of vigilance. Once motion became an orbit, narrower eyes reached for color and spectrum. Optical spectrographs hunted faint molecules and ions that whisper about ices and sunlight's scalpel. Near-infrared instruments leaned into water and carbon species that write broader accents. Polarimeters measured the angle at which scattered light prefers to swing, a signature of grain size and surface texture. Even photometric colors, split by simple filters, sketched families on color-color plots where the newcomers took their places among cousins. These details translate into density estimates and strength regimes, the raw inputs for any credible thought about influence or deflection. Radar spoke with its ancient honesty when geometry permitted. A pulse sent from one dish and received by another turns distance and spin into crisp numbers that need no intervening model. Surface roughness etches itself into speckle. Rotation inscribes a Doppler spread across the echo. Faint targets at large ranges defeat radar's reach, especially since one great instrument is now only a memory, but bistatic tricks and patient stacking can still pull shape and spin from pebbles that flit across the inner system. Each return is a portrait sketched with microwaves, a direct look instead of an inference. The curtain included rehearsal. Impact exercises unfolded like fire drills, part theatre and part sober arithmetic. Mailbox channels carried test alerts that mimicked discovery notices. Workflows widened to include emergency managers and policy tables alongside astronomers and engineers. Scenarios were drawn with playful cruelty. A small stony body, steep approach, a city on the wrong day. A larger weak one, shallow entry, a coastline that has already known disaster from water alone. Timelines were plotted backward from imagined impact clocks to identify decision points that could not slip. The lessons returned in red ink. Detection early is freedom. Late detection replaces choice with palliative options. Kinetic impact tests provided the laboratory for courage. A spacecraft hurled itself into a small moon of an asteroid and changed its orbit by a measurable breath. Telescopes read the slow dance that followed, watching debris spray and settle, then watching gravity write a new rhythm into the binary system. The physics was not a surprise to anyone who had trained under momentum conservation, but proof matters when budgets and lives are involved. The follow-up mission that mapped the crater and weighed the aftermath closed the loop from hypothesis to measurement to revised scaling laws. Those laws will govern future math when engineers sketch a craft meant to nudge a rock that is still months away, not hours. Ideas that had lived mostly on whiteboards moved into tentative engineering. A gravity tractor, hovering near a target for years, leans on Newtonian loyalty to mass, attracting mass. Ion beam shepherding promises touchless push with a hose of ions. Laser ablation dreams of painting a surface into vapor so that the exhaust becomes a thruster. Nuclear standoff, a phrase heavy with history, stays on the shelf for last-ditch cases where nothing else moves enough, mass fast enough. None of these are tricks for hurried meetings. They are strategies that only bloom if discovery buys time measured in orbits, not in sleepless nights. For fast interstellar passers, the pragmatic play is information, not interference. Computation worked as hard as glass and metal. N-body codes explored dynamical fates under the tug of planets. Hydrocodes bruised virtual asteroids with virtual strikes to calibrate cratering and momentum coupling in rubble piles and monoliths. Monte Carlo samplers walked probability spaces where impact risk lives as a cloud rather than a point. Machine learning helped triage detections, learn to ignore airplane glints and satellite streaks, learn to love the subtle motion of a real target a few pixels wide. These tools do not eliminate error. They move error into places where it can be seen and managed. Governance stitched a humane hem on the technical fabric. Notification services standardized the language of uncertainty so that scientists and officials could speak with compatible caution. International working groups set thresholds that would trigger specific actions, not as rigid laws, but as rehearsed commitments. Ownership of the sky became shared in a way that had nothing to do with borders. If an early alert falls silent because of politics, a later apology is not a remedy. The curtain only works if every hand on the rail agrees to pull together when it shakes. Education widened the base of the long game. Planetariums taught the difference between fear and preparedness. Schools used real discovery alerts to let students calculate orbits with their own hands, turning news into practice. Citizen science platforms invited volunteers to inspect subtraction images for moving dots, and they succeeded because repetition breeds skill in every field. Culture shifted a degree toward patient attention, the angle a sailing vessel finds when the wind is not quite fair, but is enough to make way if the crew is stubborn. Redundancy kept the fabric from tearing. Ground facilities failed softly to weather or hardware because others could take the handoff. Spacecraft rotated through safe modes and returned to duty without leaving gaps that mattered to the timeline. Funding plans smoothed themselves out to avoid feast and famine that leaves capability brittle. The ambition was simple to state and hard to achieve. No single point of failure should dominate the path from photon to decision. When a system honors that principle, a late-night thunderstorm in one country does not translate into a missed trajectory refinement half a world away. Even the humble craft of archiving earned a place in the ensemble. Raw data landed in repositories where calibration could be reworked as methods improve. Timestamps were synchronized to standards that forgive no sloppiness. Software was documented like a ship's log so that future teams could rebuild a pipeline without guessing at the intentions of vanished authors. The horizon here was decades, not months. A curtain cannot be mended by people who do not remember how it was woven. Documentation is memory, and memory is capability disguised as prose. Altogether, the apparatus of planetary defense looked less like a shield and more like choreography. Sensors took their places. Pipelines set tempo. Analysts improvised within practiced forms. Decision-makers stepped into the light only when the numbers asked them to. Audiences watched without panic because the narrative was steady and comprehensible. None of this guaranteed safety. It guaranteed dignity in the face of chance, and the highest art any civilization can practice is to meet randomness with grace, craft, and resolve that does not need applause to remain strong. There are places in the sky where night never quite arrives. The sun's glare floats through dust like milk in water, and in that brightness any small body can hide with effortless confidence. Ground telescopes step back from the furnace to keep optics honest and sensors alive. The result is a blind quarter where geometry conspires against vigilance. Space breaks the conspiracy. Put a watcher beyond the weather and the haze, give it eyes that read heat rather than reflected light, and the horizon changes shape. Darkness becomes a wavelength, not the absence of a star. Thermal vision rewrites the ledger of small worlds. Invisible light. A cold stone shines only because sunlight strikes it, and its surface reflects a fraction back. A dark rock can masquerade as a small bright one. In the infrared, the same rock confesses its size through the warmth it cannot help but radiate. Detectors tuned to the glow of a body, a few hundred Kelvin, gather photons that are information about diameter and emissivity rather than a riddle about albedo. A faint target that would vanish in the sun's gold becomes a steady ember against background cold. The instrument hears heat instead of hope. Orbit choice is a kind of philosophy. A sentinel near Earth shares parallax with the ground and can hand off targets easily, but it still respects safety angles that keep the sun outside its field of view. A halo around the Sun-Earth L1 point lets the telescope look sunward with a generous baffle while Earth shrinks into a manageable source of stray light. A spacecraft on an inner orbit, trailing near the path of Venus or slightly inside Earth's path, can turn outward and watch the gap that ground observatories cannot, measuring objects that approach from the morning or evening side long before the planet rolls into danger. Each placement balances duty cycle, stray light, and thermal control. The message is simple. Where the sky is bright, put a cold eye. Cold is the secret. Thermal detectors sing best when their own bodies are quiet. Cryostats draw the instrument down into a hush where silicon stops murmuring and the dark current falls away. Some missions carry liquid cryogens that boil off with a patient whisper. Others use mechanical coolers that thrum like distant bees. Multi-layer sunshields unfold into silvered origami that keeps the star's heat at bay. Baffles extend like the petals of a shadowed flower to block stray light. Every surface is black where it should swallow, reflective where it must repel, and textured where scattering would hurt. The entire craft is an argument with heat. Bandpasses are chosen like notes in a score. One channel sits near 4 microns to catch the warmest stones and the gases that sometimes ride their comae. Another rests near 6 or 10 microns where cooler grains glow and where the size signal is strong. Together, these windows let analysts separate temperature from size, then adjust for phase angle and distance to extract diameters that are more than guesses. A simple thermal model becomes a workhorse, spiked with a beaming parameter that accounts for roughness and rotation. With 2 bands, degeneracy loosens its grip. With 3, it begins to let go. The scanning strategy is choreography performed in orbit. The telescope slews on a fixed cadence, painting stripes across the sky just sunward of safe angles, then stepping forward as the spacecraft moves along its path. Each target is caught several times over days, so that motion can be measured rather than inferred. A moving point captured against the same background in 3 visits is a tracklet. Link enough tracklets into an arc, and the track becomes an orbit. The pipeline learns to love things that shift exactly as a nearby object must, learns to forget things that do not quite keep the beat. Cosmic rays leave single-frame wounds that are easy to ignore. Hot pixels are catalogued like misbehaving stars and exiled from the conversation. Zodiacal light becomes both obstacle and ally. The cloud of dust that flattens into the plane of the solar system glows in infrared, a soft curtain of emission that raises the noise floor. But the cloud is smooth on the scales that matter for moving dots. Subtract the smooth and moving lights remain like sparks leaping from a fire. Closer to the sun, the curtain brightens and subtraction grows harder. That is why orbits and baffles matter. The watcher must place itself where subtraction succeeds more often than not, and where the risk to optics is low. There is no heroism in burning sensors for one glorious frame. The long game prefers modest exposures repeated forever. False positives have personalities. Glints from spacecraft pretend to be meteoroids. Planetary ghosts sneak through optics in ways that look like motion, Mercury and Venus parade at the edge of the field, bright enough to wound any careless detector. Algorithms learn the dialect of each mischief. They reject points that share a satellite's speed across a sequence. They flag frames near bright planets as unreliable and downweight them. They pull catalogued asteroids from archives and breathe a sigh when a candidate matches a known path. The goal is to leave only the honest strangers in the net. Infrared surveys gift the ground with targets that arrive already understood. An alert carries thermal diameters with error bars, estimates of albedo, and a first guess at rotation if the flux wobbles within the visit window. Ground spectrographs, free to ignore size puzzles, can spend their minutes on composition. Photometric teams can aim for light curves, confident that their object is not a dust deceiver, but a body with a scale worth the effort. Radar, when geometry smiles, can calibrate thermal assumptions by measuring size directly, then feed that correction back to refine thousands of estimates from the infrared archive. A loop closes in quiet elegance. Latency becomes a moral as much as a metric. The sky is generous to those who respond quickly. Data flow must be engineered to move from warm sensor to cold storage to public alert in hours, not weeks. Compression schemes preserve faint flux without adding artifacts. Downlink windows are scheduled to minimize bottlenecks near perihelion seasons when targets swarm. Ground stations on multiple continents catch passes so that the spacecraft is never far from a receptive ear. The difference between an alert at noon and an alert at dawn is sometimes the difference between a missed night and an orbit that tightens with graceful ease. Cadence is time turned into safety. Repeat visits convert single detections into arcs, and arcs into predictions good enough to be trusted by decision-makers who allocate precious minutes on larger instruments. If a region of sky can be covered every 2 days with acceptable signal-to-noise, objects with a wide range of speeds will be netted. If the region can be revisited daily, fast movers reveal themselves with giddy clarity. The architecture of the survey declares its intent with cadence, and intent becomes capability when the calendar is honored for years without collapse. Constellations are a rumor that grows more credible each season. A single large eye reads the sky with authority. Several smaller eyes, spread around the sun in different orbits, could stitch together a view with fewer shadows and more parallax. The price is complexity in communication and calibration. The reward is resilience and breadth. A craft near L1, a craft trailing Earth, a craft inward near the orbit of Venus, and perhaps a craft leaning out toward L2, each covering a different wedge. The quilt would catch approaches from all directions with equal grace, and no storm of geometry would surprise the planet at an awkward hour. Calibration is a pilgrimage repeated often. Stars whose fluxes are known to the decimal serve as candles in the dark, against which instrument drift can be measured. Cold sky fields calibrate the zero. Warm planets test the bright end. Detectors age, their response sagging in patterns that only persistence can map. Software remembers these sagging maps and bends them back toward truth. Everyone in the chain learns humility. No number descends from orbit without lineage. Every lineage is checked against itself until the quiet confidence of a seasoned observer replaces the optimism of a first light ceremony. The union of infrared sentinels and ground networks matures into a craft that behaves like weather forecasting for the deep sky. Heat maps of risk evolve day by day, color-coded not for panic but for resource allocation. A faint, warm source near the glare that moves exactly as a nearby object should is promoted to priority. 100 similar sources are demoted, but not erased, because the world is full of slow surprises that ripen on their own schedule. The discipline learns to avoid drama and to honor boring continuity. Boring is what saves cities. When a new interstellar traveler wanders in from a bright quarter, the infrared watchers will be the first to feel its presence. A line of heat will cross their frames, not dazzling, simply persistent. The blind spot shrinks. The ground looks up with a plan rather than a guess. Between them, a curtain acquires more threads. None of the instruments are glamorous on their own. Together, they build a patience that outlives individual missions and even the fashions of funding. That patience is the architecture that allows a species to greet the unexpected with competence rather than noise. Warning begins as arithmetic whispered into darkness. A faint magnitude becomes a range of brightness corrected for distance and phase, then reinterpreted as an absolute magnitude that hides size behind the mask of albedo. A small bright stone and a larger dark one can share the same number, so the warning message is always tempered with humility. Yet the first conversion matters. Absolute magnitude translates into a diameter estimate that feeds models of mass and momentum. With those, numbers begin to take the shape of hours or years. A world learns how much time it has to decide what kind of response belongs to a visitor with a particular weight and a particular speed. Distance enters the equation with the gravity of a bell toll. At 2 astronomical units, a modest body is a quiet smudge that patient surveys can pick up weeks or months before any rendezvous with the inner system. At 1 astronomical unit inbound, the same object brightens quickly, but time tightens like a knot. The sky grows generous with photons only when the calendar becomes cruel. The conversion is simple. Divide the remaining path by the radial speed, and the answer lands as a hand on a clock face. A number that once felt like geometry transforms into a deadline. Velocity is the tyrant that crowns the calculation. A stone coasting on an elliptic path carries the speed of a resident. An interstellar traveler arrives with more kinetic insistence. The difference is not subtle. 40 kilometers per second against the grain of a planet's orbit compresses warning into the space between a few new moon cycles. Launch windows for any intervention decay with that same speed, their energy demands rising beyond the reach of present rockets as each week passes. The arithmetic makes no allowances for hope. It is a ledger for stamina and preparedness. Astrometry writes the fine print. Each measurement places the moving dot on a map with a small scatter of uncertainty. Link those points into a fit, propagate the fit forward, and the uncertainty blossoms into an error ellipse that stretches along the direction of motion and flares in cross-track, as small assumptions about thrust and reflection whisper their influence. The ellipse slides across the sky, and within it lives a family of possible futures. The law is clear and patient. The message is less so. Only repeated measurements shave the ellipse down to something that decision-makers can live with. Impact probabilities begin at 0 and climb in careful steps as covariance shrinks. The minimum orbit intersection distance between the path of a body and the path of Earth becomes the number that screens for attention. A small moid is not a sentence. It is an invitation to look again. When the probabilities rise above thresholds written into policy, color codes and scales come alive on briefings. The Torino scale maps combinations of probability and energy into language that the public can hear. The Palermo scale sits beside it, a logarithm that compares a predicted event to the background hazard expected from random impacts over the same time span. Low negatives soothe the pulse. Values that rise towards 0 and beyond ask for priority nights on telescopes and meetings that begin on time. The B-plane, that analytic sheet slicing space at the moment of a close approach, turns abstract concern into geometry one can sketch. A point on that plane represents a specific misdistance and angle as the visitor slides past. Hidden on that plane are keyholes, slender regions, where gravitational nudges would plant the object on a return path that intersects the planet years later. Warning arithmetic must find those threads of fate and label them clearly. A tiny shift now can avoid a rendezvous later. Without that map, a near miss could be misunderstood as safety rather than a reshuffling of risk. Non-gravitational forces write corrections in a fine hand. Sunlight heats and re-radiates, creating the Yarkovsky effect that drifts small bodies across orbital space over seasons. Jets of gas from a cometary surface push more directly but with rhythms that complicate a clean fit. Warning calculations learn to accept that thrust is part of the field, not an anomaly. Parameters enter the orbit solver that capture the average tug, and uncertainty grows honest instead of falsely tight. The gift of humility is expensive. It requires more nights of data and more patience from every reader of the numbers. Magnitude limits set by detectors define the horizon of comfort. A survey that reaches to magnitude 22 will inevitably miss bodies below a certain size until those bodies are close. A survey that reaches to magnitude 24 moves the horizon outward and trades false positives for real discoveries. The conversion from limiting magnitude to lead time is a curve that educators can place on a single sheet of paper. At a given albedo, a 100-meter rock becomes visible at a specific range, which at a given speed is a specific number of days. That sheet is a secular prayer in control rooms and ministries alike. It tells what vigilance buys. Parallax serves as a lever that multiplies confidence. Two observatories separated by the width of Earth see a fast mover a little apart at the same moment. Subtract the two views, and nearby distances reveal themselves like depth in a stereograph. The conversion from angle to range is high school trigonometry dressed in formal clothes. With range known, speed drops out of the slope of the next few measurements, and the warning clock clicks into a clearer rhythm. Mathematics becomes mercy when it turns faint lines into distances one can plan around. Decision trees grow from these numbers like disciplined vines. If the clock reads years, the choices include reconnaissance spacecraft, slow deflection plans, or at minimum, a hardened civil defense program that moves populations out of harm in a measured way. If the clock reads months, the chance for launch narrows to fast flybys that refine size and structure, while civil authorities rehearse evacuation and shelter plans with a sincerity that leaves no room for theatre. If the clock reads weeks, arithmetic converts into logistics almost immediately. Roads, fuel, hospitals, communications, and the unglamorous art of telling the public the truth without seeding panic become primary. The arithmetic does not decide ethics, but it forces honesty about which ethics can be enacted. Launch energy is a cousin to warning time. Delta V requirements grow as the object dives deeper into the sun's well. A mission conceived at discovery must thread the curve between feasibility and urgency. Spiral out slowly with electric propulsion, and the craft will arrive after the event. Blast out rapidly on chemical engines, and payload shrinks to an instrument suite rather than a deflector. The algebra that relates launch date, target ephemeris, and required energy is plain and strict. It is also the reason that early discovery has more value than any other single improvement. More years expand the solution space. Fewer years collapse it to postcards. Error management is culture, not just calculation. When an early arc suggests a non-zero chance of impact, the temptation to round to comfort must be resisted. The opposite temptation, to inflate small probabilities for attention, must also be resisted. The proper path threads between them. Communicate the current probability, the cadence of updates, the size range that matters, and the milestones that will either raise or lower concern. The arithmetic supplies these numbers. The culture chooses to say them out loud, with the consistency that builds trust. Evacuation thresholds are written in tables that carry no romance and great consequence. A projected impact footprint might cross water and land and cities in a band of uncertainty hundreds of kilometers wide. As new data narrow the band, warnings tighten into instructions. The cost of moving millions is counted against the risk of doing nothing. The metric is expected energy release, ground overpressure, thermal radiation, tsunami likelihood, if water is the medium, and local infrastructure's capacity to absorb shock. Each variable is a formula tied to size and speed and angle. Each formula was once a research paper and a laboratory test. In the moment, they become numbers on a page that decide whether school buses roll. Continental coordination borrows the same arithmetic to resolve priorities. One hemisphere may face a higher probability band, but tracking telescopes sit in the other. Clouds drift in unfortunate patterns. A space-based asset can fill the gap only if its schedule and pointing limits align with the need. These conflicts resolve when numbers are clear and shared. A degree of phase space defined in the B-plane is more persuasive than a vague description of maybe. The curtain holds when every participant can read the same chart and see the same ellipse shrink as work is done. Retrospective lessons complete the cycle. After a passer moves on, or an approaching body is refined into harmlessness, analysts compare predicted magnitudes to the light that actually arrived, predicted positions to the path actually taken, and calculated risks to the headlines that were written. The differences become calibration for the next encounter. warning arithmetic is alive. It learns. Each cycle removes a small bias, tightens a loose assumption, and smooths a rough edge in software or procedure. Over years, that quiet work becomes a far more powerful defense than any last-minute gesture. In the end, the arithmetic of warning is a discipline of timekeeping. It measures distance with light, speed with slope, mass with a shimmer of heat, and consequence with the sober scales of impact energy. It translates those measures into calendars and clocks that people can live by. When done well, it replaces surprise with foreknowledge and fear with orderly intention. Numbers do not love or grieve. They do something kinder. They reveal how long a species has to transform awareness into action, and how precisely that action must be aimed. The problem wears a simple face. A small world approaches with a closing speed that turns kilometers into casual steps. The mission is to change where it will be at a specific future moment by a distance larger than Earth. Everything that follows is a dialogue between momentum and time. At long lead times, a whisper of acceleration tilts the path enough for a safe miss. At short lead times, even a shout accomplishes almost nothing. The geometry rewards patience. The physics punishes hurry. Momentum coupling is the first lever. Strike a body, and it answers with inertia. The impulse delivered is the mass of the interceptor multiplied by the relative velocity, multiplied again by the amplification that debris adds if the target throws material forward in a plume. That amplification, named by a single Greek letter in the literature, grows when the target is cohesive enough to eject a focused spray. It shrinks when the target is a foam of rubble that absorbs shock like a pillow. An interstellar traveler of porous ice and organics is likely to drink the blow rather than ring like a bell. The crater forms, grains decouple, and momentum disappears into heat and rearranged pores. If the plume rises, the missed distance grows. If it does not, the effort becomes a scratch on a fast-passing stone. Energy is the second lever, and it scales badly with lateness. Kinetic energy rises with the square of relative speed. For an interceptor closing head-on, that speed is already extreme. A collision transfers some of that energy to the target as shock, but most of it flees as vapor and ejecta. Nuclear options carry more energy per kilogram than any chemical system, and can couple impulse at a standoff distance rather than at a crater floor, yet timing rules here as well. The same pulse that would produce a friendly millimeter per second of change years in advance becomes a useless breath weeks before arrival, its imparted delta V translating into a miss distance measured in atmospheric scale heights rather than planet radii. Guidance enters as a constraint rather than a gift. To touch a target that is small, faint, and moving across the starfield at tens of kilometers per second requires relative navigation that tolerates almost no delay. Late course corrections demand thrusters that pivot a spacecraft in minutes without spinning instruments into nausea. Cameras must lock onto a point wrapped in a coma that brightens and fades with geometry. Onboard autonomy must discriminate between a speck and a hot pixel, while the light time delay to Earth forbids real-time help. Even a perfect hit can become strategically meaningless if the calendar refuses to give that hit room to matter. Material science complicates every plan. A monolithic rock conducts shock crisply. Stress waves travel, fractures climb, chunks depart, ejecta pour forward, and the hoped-for momentum boost appears. A rubble pile spreads shock into grains that tumble and settle. Pores collapse, and internal voids gulp the energy. The surface slumps rather than explodes. Laser ablation prefers coherent surfaces that vaporize into jets. Ion beam shepherding prefers surfaces that hold on to charge and respond smoothly to a push. Gravity tractors prefer bodies that will stay calm, while a companion hangs nearby and tugs for years. In short windows and at high speeds, none of these preferences are likely to be satisfied. The traveler arrives as the material the universe most often builds for free, which is fragile, friable, and obstinately unsuited to being shoved hard. Angles offer a third lever hidden inside the second. A tiny change in velocity produces a large change in position if applied far from the rendezvous. In the language of targeting, the B-plane keyholes that translate near misses into future impacts are narrow threads. Nudging the path so that it passes outside a keyhole years in advance is a modest assignment. Missing the keyhole by a hair a month in advance may require an impulse that no current rocket can deliver. The cure is to move choice upstream. The means is to see early and to stage capability where it can leave the pad when the math is still generous. Architecture adapts when the arithmetic is honest. A rapid response deflection mission imagines propellant waiting in high orbit. Shields baked and ready. Avionics warmed by slow power. A tug with high specific impulse engines keeps station near a depot, then sprints to deliver a small craft to the path of a slow hazard long before the hazard becomes a headline. For interstellar passers, the mission profile shifts from push to probe. A fast flyby with efficient sensors reads size, density, spin, and structure, feeding numbers into civil plans on the ground that may call for evacuation rather than bravado. The line between reconnaissance and deflection is drawn by time, not by courage. Still, theory sketches the edges of what might be possible if years were available. A gravity tractor hangs a few body radii away and leans gently with its own mass. Over thousands of hours, the mutual attraction shifts the comet's path with exquisite control and no risk of fragmentation. Ion beam shepherding focuses an exhaust plume onto the surface, adding a tug without touching. Surface landers, small and numerous, fire pellets or low-power lasers to lift local jets that sum into a slow current. Each option prefers a quiet sky and a calendar spread like a calm sea. Each becomes theatre in a storm of weeks. The worst-case scenario is the temptation to shatter. Fragmentation glitters with apparent success because many small pieces look less dangerous than one large one. In a thick atmosphere, that intuition may reward. Fragments ablate and fade before they reach the ground. Over water, fragments can still collaborate into a common shock and a common wave. Over land, a swarm of large pieces can turn a line into a swath, and fragments are harder to predict. Rubble blooms with unpredictable cross-sections and spins, resisting precise tracking just when precise tracking matters most. The physics offers small wins and large regrets in the same package. A species that aims to stay civilized chooses deflection over demolition whenever the clock allows. Orbit matching sharpens the problem of meeting a fast body in the first place. Interceptors must climb or dive through the sun's field to reach a crossing point. Chemical propulsion grants quick thrust, but drinks propellant that grows heavy. Solar electric propulsion saves mass but spends months warming up to a pace that can intercept anything but the laziest rock. Nuclear thermal dreams of high thrust and high efficiency together, and will remain a dream until rules and trust catch up to need. In every chart, the reachable set of targets balloons when the launch date moves earlier. No motor can buy back lost time at a bargain price. Against this physics, the most powerful tool is a plodding one. An extra year converts a required delta V from meters per second to millimeters per second. An extra decade makes tractors viable, where impactors once seemed mandatory. The paradox is that to own those years, institutions must move in months. Surveys must be funded, software deployed, launches rehearsed, and depots filled long before any single object demands attention. A curtain that appears overnight is an illusion. The real fabric is woven during quiet seasons when attention is hardest to maintain and gratitude is small. Ethics sit beside engineering because thresholds are choices. When a probability crosses a number, a mission director signs a paper that spends public treasure and risks public hardware. When a later update lowers the probability, arguments follow about whether caution was expensive. The correct response is to make those thresholds public in advance, to explain how probability and energy combine into triggers, and to design missions that can retarget to useful science when the crisis dissolves. A culture that makes reversible choices is more resilient than a culture that only knows final bets. There is also the humility of geometry. Some trajectories simply will not yield to intervention. A high-inclination hyperbolic path that threads the day side near the sun may be unseeable early and unreachable late. The answer to such a path is not a fanciful intercept. It is civil defense on the ground and better eyes in space for the next time. A plan that assumes perfection is not a plan. It is a story told to avoid the hard work of acknowledging limits. And there are glimpses of future leverage worth growing toward. Solar-pumped lasers stationed far from Earth might sip energy from the star and bank it in beams calibrated to heat a surface from tens of thousands of kilometers away. Magnetic sails pushed by directed plasma could deliver impulses without propellant. Swarms of micro-impactors released in a timed sequence could approximate a continuous thrust without requiring a single, flawless hit. Each idea has a calendar attached measured in decades. Each offers a path toward making small nudges commonplace rather than heroic. Strip the problem to its frame, and a clear sentence remains. Moving mountains at kilometers per second is not about brute force. It is about finding the earliest moment when a feather can become decisive. Physics agrees to cooperate if asked in time. It grows stern when asked late. The craft, then, is to keep the feather ready, to keep the clock honest, and to accept that sometimes the right answer is to step aside while the sky writes its fast sentence across empty ocean or unpeopled field. That acceptance is not surrender. It is the discipline of serving life with numbers rather than with noise. Practice is the gentle word for rehearsing what no one wants to perform. Laboratories, missions, and supercomputers become safe stages where dangerous plays are explored without casualties. Inside concrete rooms full of cables and vacuum valves, a tiny sphere races down a barrel filled with hydrogen and helium to meet a block of porous rock at several kilometers per second. Cameras blink in a millionth of a second cadence to watch shock cones bloom. Fragments lift like pollen. A crater scallops outward and then freezes into silence. Scaling laws are written from such moments, equations that translate centimeter scars into kilometer consequences. When those laws appear later in a spreadsheet that a planner will read, they carry the smell of propellant and the afterimage of a flash. Vertical ranges add a second grammar. Gravity acts along the same line as the incoming shot, so ejector rise and curl as they would on a world without air. The measured arc of each grain becomes a line in a code that models momentum transfer. At the bottom of these tests waits the number that engineers love. How much extra push does a plume of ejector give beyond the direct shove of an impact? That multiplier adjusts design. Small craft grow large or shrink depending on it. Launches are added or cancelled. It is a humble number, but humility in the lab becomes confidence in space. Shock physics makes its own weather. Capacitor banks breathe for a moment and translate stored electricity into a pulse that crushes a target between anvils of light. The shock front races across crystals, reorganizing atoms into phases that nature rarely assembles without trauma. In the aftermath, material memory is inspected. Some clays stiffen under shock. Some ices turn to spongy mosaics. Some organics char into skins that alter how sunlight is absorbed. Every change feeds into deflection plans because a surface that hardens under stress ejects dust differently than one that slumps. A tiny difference matters when the desired outcome is a millimeter per second added to a mountain. Lasers offer a gentler rehearsal for strategies that propose to peel a surface into vapor. A beam rests upon dark rock in vacuum, and heat walks inward through pores and fractures. Gas jets sneak out along weak seams and carry grit that becomes the exhaust of a makeshift engine. Cameras watch the jet flicker as the spot moves, and balances measure the net push down to fractions of a newton. These experiments find the thresholds where sublimation begins, the angles that make a plume most efficient, the colors of light that penetrate the skin best. The results reveal what could be done slowly and carefully, and what will never be practical in a hurry. Granular physics turns out to be a central character in every instruction. Regolith behaves like neither a solid nor a fluid, and sometimes pretends to be both. In drop towers, tubs of beads and powders free fall for seconds while mechanical shakers stir them into motion. In parabolic flights, the same tubs float in brief weightlessness, while cameras map avalanches that obey their own strange ethics. Pillars of grains stand where any engineer would have predicted collapse. Deep voids swallow projectiles as if mass were a rumor. These rehearsals explain why a spacecraft can sink halfway into a surface with a gentle touch, and why an impact can puff rather than explode. Deflection hopes ride on these subtleties. Supercomputers knit the pieces together into long narratives that no single experiment can hold. Smoothed particle hydrodynamics treats a target as a sea of virtual parcels that feel pressure, tension, and gravity. Each parcel remembers its neighbors, and the ensemble remembers strength, porosity, and fracture. Hypervelocity strikes play out in these seas, and the aftermath evolves for minutes of simulated time until fragments find the shapes they will carry away. Discrete element methods go further into the grain, letting each boulder collide, roll, and jam. Bonds break where stress finds them, and a rubble pile learns to be itself. Codes switch gravity on and off to mimic capture, flyby, or long companionship with a tug. In every run, the question recurs: how much momentum can be coupled without turning a single problem into a cloud of smaller, trickier problems? Parallel to impact dreams, the sky itself is made artificial to test the eyes. Survey pipelines are fed streams of synthetic stars and synthetic streaks that mimic aircraft glints, satellites, and cosmic rays. Inside that noise, fake asteroids and comets are planted with carefully chosen speeds and angles. The pipeline must promote the fakes that behave like reality and reject the clever decoys. Teams score themselves honestly. False positives are counted. Missed detections are owned in reports that do not flinch. Over months, software grows less naive, and the rate at which real rocks are caught increases without the headlines that follow a launch. Missions serve as the most persuasive classrooms. A small spacecraft once gave itself to a small moon and returned momentum as a gift to 1,000 plots and charts. Telescopes listened to the change in rhythm and calibrated earlier theories about how ejecta carry impulse. Another mission circled that same moon later and read the crater like a book, measuring rim height, melt, and boulder fields so that the scaling laws could be revised with gratitude. Elsewhere, a sampler's touch taught that some rubble piles are as loose as breath. The foot sank deep, and grains ran like a whisper of rain. That single moment rewrote assumptions about surface strength across an entire population of targets. Future deflection plans inherit the lesson. Never assume firmness where microgravity and time have made lace. Re-entry provides its own sandboxes where air becomes part of the script. Wind tunnels push hypersonic flows across scaled models to watch shock layers detach and reattach. Heat shields char in chambers where plasmas gnaw at them with the chemistry of falling fire. From these trials rise better maps of where an object will break, how a train of fragments will spread, and how much of the original mass the atmosphere will convert into light and dust. Civil defense needs such maps. A model of airburst pressure is not a curiosity. It is a basis for deciding which windows should be taped and which hospitals should expect glass wounds. Ocean basins join the rehearsal with careful gravity waves in long tanks, where a falling mass is mimicked by a sliding wedge or a transient pressure pulse on the surface. Sensors trace the first crest, the energy in the second, the run-up onto sloped beaches dotted with model buildings. Computer models of wave propagation digest these measurements and learn to carry a disturbance for thousands of kilometers around a cape, through a strait, onto a coast. Nothing theatrical is gained by pretending an impact at sea is gentle. Nothing practical is gained by confusing every splash with catastrophe. Only measurement calibrates the middle where most realities live. The rehearsal extends into rooms with no instruments at all, only maps, clocks, and a willingness to tell the truth. Tabletop exercises gather astronomers, emergency managers, diplomats, and voices from public health and power grids. A scenario is dealt like a hand of cards. Probability percentage, size range, time to close approach, last safe launch date. Debris risk for satellites. Each day the scenario changes with a new brief. Decisions are recorded. Lines of authority are tested. Press statements are drafted and criticized before any camera sees them. In the quiet debrief, a lesson as simple as a phone number saved correctly can be worth 1,000 words of doctrine. Practice removes friction. Removing friction buys time. Even culture becomes a sandbox when museums, schools, and city councils run drills that look like weather preparation but smell faintly of starlight. Sirens are not required. Clear language is. If a forecast footprint spans a province, Buses must know their routes as surely as telescopes know their fields. Communities that have practiced fire, flood, and wind learn to add sky to their list without panic. The curriculum is practical and dull. It is also sacred. It protects the future from improvisation at the worst possible hour. Engineering rehearsal includes failure by design. Small propulsion systems are pushed until valves stick and tanks ring with pressure wave harmonics. Detectors are baked and frozen until dead pixels reveal where margins truly lie. Software is fed inputs designed to confuse it. Awkward timestamps, missing headers, reversed axes. Teams then write the memos that no one loves to write. This broke because we assumed. This failed because we hurried. The memos become architecture. Architecture becomes reliability that looks like luck when the real sky demands a performance. Time itself is a laboratory. Missions that last long enough watch seasonal cycles on asteroids and comets, see jets wake and sleep, see boulders creep downhill by fractions of a millimeter each orbit. A patient instrument on a patient spacecraft improves models simply by refusing to blink. The same patience applied to data archives yields treasures. Old frames are reprocessed with new algorithms and reveal faint trails that were invisible before. A comet's awakening is traced back an extra month. A hazardous orbit is recognized years earlier than memory allows. Practice is not only in the future tense, it is a rereading of the past with wiser eyes. Beneath all of this lies curation. Samples retrieved from ancient bodies sit behind glass and nitrogen, tagged with the histories of their collection. These pieces become standards against which infrared spectra are compared, against which radar polarizations are understood. The grain that crumbled in a clean room explains why a crater on a distant moon looks the way it does in microwave light. Museums become quiet laboratories where time moves slowly and conclusions move slower still. In that slowness, instruments for tomorrow are tuned. The end of rehearsal is not applause but a file stored correctly. A valve replaced before it fails in the field. A code branch merged after review. A person trained to make a hard call at 3 a.m. without trembling. Sandboxes do not promise mastery. They promise fewer surprises and kinder margins when surprise is unavoidable. In their patient dust, a civilization sets out its tools, measures them against the work that may come, and accepts with clear eyes that the finest performance is the one that never needs to leave rehearsal, because watchfulness made the premiere unnecessary. Authority gathers quietly, where numbers meet consequence. A handful of probabilities stand beside projected energies and timescales, and from that table emerges a question that is never mechanical. Who decides to act, and when? The answer is a chain built from consent rather than command, a path that runs from discovery rooms lit by monitors to chambers where elected voices speak in measured tones. Along the path, thresholds are set like tide marks on stone. Cross this line, and the color on a chart deepens. Cross the next, and a dormant plan stirs. The first link is technical, but its tone is civic. Astronomers agree in advance how uncertainty is expressed. Significant figures are chosen not for grandeur, but for clarity. A briefing expresses a probability with a confidence interval and a cadence for updates. Behind the scenes, a small council of peers audits the math before a wider alert flows. This is consent in miniature. One mind trusts another because the process is legible. The process is legible because it has been rehearsed and opened to critique when the sky was calm. Past the technical rooms, language changes, register. Risk scales that the public can understand are paired with the more austere indices that specialists prefer. A color communicates urgency. A number communicates weight. Neither is complete without the other. Policies decide which colors open doors at emergency agencies, which numbers unlock budgets for rapid observations or satellite time. The thresholds are not secret. They are written down and published so that changing them is an act that must be explained. Transparency is not decoration here. It is the solvent that keeps trust from hardening into suspicion. Consent widens as national lines enter the map. An object does not respect borders. A path across the sky implies a band on the ground that may cross seas and nations. Protocol recognizes this geometry before politics has a chance to distort it. Notifications go to all potentially affected governments at once, not in order of influence but in order of relevance. The message contains the same plots that the scientists see. Nothing is simplified to the point of condescension. Nothing is inflated for drama. The consistency of these packets is a social contract that replaces rumor with structure. Decision gates are written as if they were engineering because that is the only way to keep argument from devouring time. A first gate triggers when impact probability exceeds a small percentage and the energy estimate surpasses a threshold that would injure a city or coast. That gate funds more eyes on the target, commits radio and infrared assets, and schedules emergency tabletop exercises in the likely footprint. A second gate triggers when probability climbs further and warning time settles into months. That gate authorizes a pre-mission to refine size and structure, and it activates civil plans that move hospitals, fuel, and food along corridors without yet moving people. A third gate belongs to the rarest cases, when weeks remain and probability hardens. That gate releases evacuation orders in zones that have practiced their routes and routes for their animals, and it convenes heads of state to consider whether a launch makes sense under the tyranny of time. Each gate can be reversed if new data soften the threat. Reversibility is written into the design, because credibility depends on the ability to stand down without shame. Global governance provides a table where these gates are respected across languages and interests. Representatives convene with the same charts on screens in front of them, not paraphrases. Each delegation brings experts who can interrogate the math in real time. Observers from neutral institutions verify the provenance of key data. A log records who spoke, who consented, and which caveats were attached. The log is part of the social license to act. If a later inquiry asks why a city was emptied or a rocket launched, the record shows the chain of reasoning rather than a chain of names. Liability grows teeth once action enters space. A craft that misses its target by a breath might seed debris that endangers other satellites. A deflection that lengthens a path could change a harmless near miss into a future keyhole. Protocol therefore includes indemnity funds and insurance pools that compensate damage without requiring a courtroom to interpret celestial mechanics after the fact. Nations agree to shoulder proportional costs based on wealth and based on benefit, since some will be spared more than others. This arithmetic is pre-negotiated in calmer seasons, so that the hardest hours are not wasted on price. Consent is not merely governmental. Communities hold a veto that operates through culture. Evacuation orders succeed when people believe that those who issue them will also answer for their consequences. That belief is grown by respecting dignity in drills, by respecting language in messaging, and by sharing the uncertainty honestly. A chart that shows 2 possible impact corridors is not an embarrassment. It is a map of how knowledge sharpens. People can live with uncertainty if it is not used as a pretext to speak to them as if they were children. Misinformation acts like a contagion timed to the clock of events. Protocol assigns a role to communicators, who are trained to speak plainly, calmly, and often. A single website collects updates, retains older versions for accountability, and shows the time of next revision so that absence does not foment anxiety. Social channels carry the same words, formatted for small screens but intact in meaning. That uniformity is not blandness. It is a technique for defeating the temptation to improvise under pressure. Variance in message is treated as a bug and corrected in daylight. Security lives in the seams. Data pipelines are hardened against tampering, not because anyone expects malice, but because an unprotected channel invites its own omen. Telemetry is signed and time-stamped. Archives are mirrored across neutral jurisdictions, so that no one actor can erase a difficult night. The act of publishing to the world becomes proof of integrity. If anyone seeks to rewrite a number later, the discrepancy will be visible in a dozen caches. These measures are mundane and essential. Trust loves redundancy. Ethics are encoded where the numbers are most sterile. A deflection that shifts a risk corridor from one nation to another is not a technical success if it violates consent. Protocol insists that no redirection is attempted without the agreement of those who inherit the small chance of harm. If agreement cannot be reached, the default is civil defense, not unilateral action. This slows some dreams and accelerates some honesty. It also builds legitimacy that will be needed for the long century of vigilance ahead. Representation matters in the rooms where thresholds are set. Voices from coastal communities, indigenous councils, small island states, and landlocked regions all speak to different forms of vulnerability. A single impact energy number hides the plural realities of infrastructure, poverty, and resilience. Protocols therefore contain adjustments that translate physical damage into human consequence. A ground over pressure that a wealthy city can survive may be a catastrophe where buildings are unreinforced and hospitals thin. The thresholds bend to reflect that difference. Consent is respected when context is not erased. Records of action are treated as a commons. After any episode, whether it ends in silence or sirens, the plots, emails, and decisions are placed into an archive with personal data redacted but logic intact. Students can study the arc of uncertainty narrowing. Engineers can study the moments where communication slowed. Lawyers can study the clauses that either smoothed or snarled international consent. Culture learns fastest when its mistakes are preserved without stigma and when its successes are recorded without swagger. Funding flows along the same channels as authority. A protocol that declares a certain risk level must be paired with a fund that unlocks automatically at that level. Otherwise, the declaration is theatre. The fund pays for telescope time, satellite retasking, overtime for emergency staff, transport for patients, and the quiet expenses that do not fit into stories. A receipt for bottled water in a distant town matters as much to the outcome as a successful orbital refinement. Consent collapses if the money arrives late to the people who did everything right. Counterpart agreements are prepared for the rare options that carry special weight. If a standoff nuclear device is ever considered for a distant and leisurely target, the legal and moral scaffolding must be in place long before any launch is contemplated. Verification regimes become part of consent. Inspectors from many nations watch, measure, and report. The device is built to fail safe in ways that prevent repurposing. The public debate is not suppressed. It is invited into well-lit halls where the trade-offs are described with numbers and with care. Silence is corrosive here. Speech is stabilizing. Consent also lives in small gestures that are easy to ignore. A scientist credits a colleague in another country whose night of work tightened an orbit that moved a threshold a single shade. A local mayor receives an early call rather than a press release. A translator is paid to make sure a rural radio station carries instructions in the language that grandparents speak. These are not sentimental details. They are the ligaments in the chain. Without them, authority becomes brittle and snaps under stress. The long game of governance is patient enough to outlast administrations and fashions. Protocols are reread each year with a pencil rather than a trumpet. Thresholds shift as instruments improve. Training is funded even when the sky feels quiet. The measure of success is not an act of heroism, but a spreadsheet that shows fewer minutes between a discovery and an alert, fewer contradictions between agencies, fewer surprises at boundary crossings where one jurisdiction hands off to another. Consent rewards this humility with durability. At the end of the chain stands a single person who must sign a document at an hour when sleep would be kind. That signature is not a flourish. It is the visible end of a long thread knotted by thousands of practical decisions made in calm. The document may authorize a launch, an evacuation, or a stand down. Whatever it orders, it rests on thresholds that were argued and agreed upon before the sky delivered its test. The next morning, that person will face praise or criticism. The chain ensures that the burden is borne by a system, not by one set of shoulders alone. That is the purpose of consent. It spreads weight so that choices can be made without breaking the hands that hold the pen. A third wanderer changes arithmetic into geography. One arrival could be a coincidence. Two hint at a pattern. Three begin to sketch a map of traffic through the solar neighborhood. With another messenger logged in the ledger, the background becomes visible, like stars that only resolve when a telescope has stared long enough. The sky is not empty space, with a few dramatic interruptions. It is a slow river full of small boats, most passing without notice, a minority close enough to leave ripples in a planet's attention. Population estimates breathe through detection. Telescopes see only what crosses their limits of brightness and cadence. From that thin slice, statisticians reach into the unseen and pull out a density, a number of bodies per cubic astronomical unit, drifting through the local interstellar medium. The latest edition shrinks error bars on that density, not by magic, but by the patient trick of counting. Each new point narrows the violin of uncertainty. The curve of plausible populations tightens, and a planet can begin to speak of expectation rather than surprise. The language becomes one of flux rather than anecdote, a rate measured in visitors per decade at sizes that matter. Size distributions shape the story with more intensity than any single discovery. Small bodies are more numerous than large ones. The mathematics of shattering and accretion favors fragments. If detections cluster near a particular scale, that is as much a commentary on instrument sensitivity as it is on cosmic supply. Translate the detections with honest models of brightness, albedo, and activity, and a curve emerges where 10 times fewer bodies exist at 10 times the diameter. A fresh interstellar comet places another anchor on that curve. The anchor drags the inferred mass of debris ejected by young planetary systems into a narrower band, a quieter claim about how much rock and ice every star must throw away to sculpt its family of planets. Origin leans into those numbers like a crosswind. A single system could never populate the entire local volume. The traffic must be ambient, an aggregate of many nurseries that shed their surplus. Density estimates now suggest that every star with giant planets ejects a significant fraction of its small bodies over time. The ejections are not acts of rage. They are the inevitable bookkeeping of gravity. Planets grow, migrate, and trade energy with leftovers. Some leftovers are promoted into long-period orbits within a home cloud. Others are dismissed with a surplus of speed. Over millions of years, the dismissed become a background current flowing through the galaxy's disk. Directionality, once a conjecture, is now a measurable property. Radiance of arrival plotted on a globe of the sky begin to show whether traffic prefers the solar apex or is closer to isotropic. The plot remains sparse, but sparsity does not mean silence. If the points distribute widely, confidence grows that local space is stirred and mixed by the passing of stars and the mild turbulence of interstellar clouds. If clusters appear along certain great circles, then streamlike coherence may linger from common histories. The third point does not complete a constellation, but it teaches that surveys must not fixate only on one favored direction. A network learns to wait for visitors from the east and from the west with equal patience. Activity imprints itself on census in tricky ways. A body that vents even a little can be discovered at greater distances than one that remains inert, because the surrounding coma fattens the signal. A census bias toward active bodies risks undercounting the dry population. Correcting for this bias requires models of sublimation thresholds, thermal inertia, and crust strength. Add another moderately active traveler, and the correction can be recalibrated. The balance between active interstellar comets and inactive interstellar asteroids shifts slightly, and with it the estimate of how much of the ejected material was icy at birth. That balance feeds back into theories of disk temperature profiles around young stars and into the likely locations of snow lines when giant planets raise their tides. Chemistry, even at low resolution, pushes on the census from a different direction. If the third visitor's volatiles sit comfortably within the broad scatter of familiar comets, then a claim strengthens that formation conditions across many stellar nurseries overlap more than they diverge. Homogeneity, at the level of major species, does not erase diversity in detail. It does, however, justify assuming that unknown interstellar bodies will not be alchemical strangers. Census becomes a count of kin, not a search for anomalies. That shift matters for planetary defense. Strategies can be designed for likely material classes rather than for miracles. Speed is both a detection parameter and a demographic clue. High hyperbolic excess velocities are rare under most ejection scenarios, so an object that tears through with unusual haste would hint at an origin in a recent violent event. The third messenger arrived fast enough to be free, slow enough to be ordinary among the free. That ordinariness is itself informative. It argues for a background of ejections powered by steady interactions rather than catastrophes. Planetary systems are grinders, not explosive factories, and the grind fills space with migrants whose energies cluster around a modest surplus. Counting visitors rewrites budgets in quiet committee rooms. With a better flux estimate, mission designers can project how often a suitable target will pass within reach of fast reconnaissance. Launchers can be kept warm with realistic cadence. Instrument suites can be standardized for quick integration rather than invented anew for a once-in-a-century event. Even museums can plan exhibits that will not become fossils of promise. When a rate stabilizes into a number with comforting digits, institutions find the courage to invest in continuity rather than one-time heroics. The census stands on the shoulders of cadence. Surveys that view the same sky every few nights will find a certain class of wanderers. Double the cadence, and the net catches faster fish. Increased depth and smaller bodies are found farther out, where lead time is measured in seasons rather than evenings. The third entry on the list of interstellar visitors hardens the argument for combining depth and cadence in new facilities. The return on that investment is not only planetary safety, it is a map of small body populations that acts as a fossil record of planet building across the galaxy. Biases confess themselves more readily as the sample grows. All sky surveys avoid bright twilight. Sunward approaches are undercounted. Southern skies receive more attention during certain months. Fields rich with background stars make detection harder. With more detections, corrections for these biases become less reliant on simulation and more on reality. Weighting factors in the census shift accordingly, and the inferred isotropy or anisotropy of the flux adjusts. Confidence appears not as bravado, but as error bars that no longer dominate the page. Numbers of this kind invite creativity outside of astronomy. Biochemists sketch boundary conditions for the transfer of complex molecules between systems and are more willing to study the survivability of organics under cosmic rays when the traffic of carriers is no longer speculative. Philosophers who worry about uniqueness gain a dataset that makes kinship a statistical expectation. Writers who imagine civilizations watching the same sky find a point of contact in the shared experience of counting. All of it flows toward an estimate with human meaning. How often will a modest interstellar body pass near enough for the unaided eye to notice with a dark sky? How often will one grow bright enough to gather crowds in city parks? How often will one be large enough to appear in civil defense plans, not as a fantasy but as a line item in a practiced handbook? The census tampers with myth in a gentle way, replacing omen with trend. With a third point on the graph, trend begins to exist as something other than faith. There is also chastening news folded into the count. Even with improving surveys, many interstellar visitors will pass unseen. The blind quarter near the sun will continue to betray watchers until spaceborne infrared eyes operate with sufficient sensitivity and cadence. Weather will steal nights at the worst times. Priorities will collide. Some objects will carry surfaces so dark that they defy detection until they are rudely close. A mature census admits what it cannot see and includes that admission in its uncertainties. Honesty becomes a form of safety. Projections grow bolder with each logged traveler. Extrapolate the current rate forward under planned instruments, and a picture forms of a century filled with dozens of opportunities for science and discipline for defense. The projections are not promises, they are scaffolds. On them, young researchers can hang careers, and engineers can hang plans for vehicles that are built to wait. The waiting becomes purposeful rather than wasteful when the clock is set by statistics rather than hope. The third messenger is not a celebrity. It is a data point with a heartbeat. In its faint tail and faint thermal glow live the parameters that nudge theory toward maturity. The count it joins is a count of absences as much as of presences, an inference about the common fate of worlds that begin crowded and end arranged. If small bodies traveling between stars are numerous, then every planet sits beside a porous border. Exchange becomes a theme not only of trade in stories, but of matter in space. A stone that learned exile becomes the ambassador for a truth as old as dust. The galaxy is a commons. Paths cross. Histories mingle. The census is the ledger where that mingling is written in numbers that do not need metaphor to be meaningful. A long vigil begins with a ledger. Numbers become scaffolding for patience, and patience becomes architecture that is visible only in its reliability. A century of watchfulness asks for budgets that breathe like lungs rather than like applause. Multi-year lines replace single-year spikes. Endowments seeded in quiet seasons throw off steady income for the unglamorous work of calibration, maintenance, and staffing. Insurance pools protect night after night of observations from the accidents of weather and hardware. Procurement cycles acknowledge that instruments age and that replacing them on time is not extravagance, but continuity. The culture learns to celebrate the uneventful balance sheet that keeps eyes open even when headlines look away. Training follows budgets, as vines follow a trellis. Apprenticeships knit young hands to seasoned ones in control rooms, where the lights are low and the responsibilities high. Curricula at universities quietly shift to include pipelines and telemetry, not only theory and elegance. Machine learning appears as a tool, not a fetish. Students learn how to tune a mount, how to choose a cadence, how to speak across disciplines without turning precision into mush. Summer schools convene on mountaintops and in desert arrays where dawn smells of metal and frost, and where mentors show how to keep a survey alive when something trivial goes wrong at the worst possible hour. A century-long posture cannot be staffed by talent that arrives only for the fireworks. It must be held by people who love steady labor. Redundancy is written like a poem that repeats without becoming dull. Every function in the chain from photon to decision has a backup that is different enough to fail in a different way. A wide field imager in the north has a cousin in the south. A spaceborne infrared eye has a ground-based partner that can confirm thermal ghosts with visible light when angles allow. Alerts travel on multiple networks that share no single point of vulnerability. Archives live in more than one jurisdiction and speak more than one file format. Even key people have their mirrors, trained in pairs, so that illness or departure is a bruise, not a break. The design principle is plain. Failure is expected. Collapse is not. Technology refresh becomes a ritual that resists novelty worship and resists stagnation in the same breath. Roadmaps are written for decades, with milestones that describe not only what will be built, but what will be retired. Legacy systems are wrapped in interfaces that keep their wisdom available while freeing developers to create new tools. A philosophy of small modular upgrades sits beside occasional leaps, so that the curtain can thicken thread by thread without tearing itself apart for a trend. Vendors are cultivated as partners who understand that profit sits comfortably beside mission when both sides tell the truth about schedules and risk. Data stewardship is sanctified in daily habits, rather than in ceremonial speeches. Timestamps carry absolute references. Calibration frames are stored with the same respect granted to glamorous images of visitors. Pipelines are documented as if they were literature, with comments that explain not only what happens but why. Version control is enforced by culture, not only by policy. Audits walk the trail from a published plot back to the raw sensor numbers and later forward again, checking that no step was a private interpretation that cannot be repeated. When a century is the horizon, memory must be designed rather than assumed. Governance adopts a tempo that blends urgency with ritual. Boards meet frequently enough to act and infrequently enough to think. Membership rotates to avoid capture by fashion. Ethics committees sit near the center of power, not at the perimeter, and they are populated by scientists, engineers, and citizens who understand the gravity of choices that move people or machines on short notice. Public minutes create legitimacy that can be spent only once, so they are written with care and honesty. A century of vigilance must be a century of clear speech. Community engagement is threaded through schoolyards and city councils, not parked in a public relations office. Teachers receive kits that turn real alerts into lessons. Local observatories hold nights where residents can see how subtraction images reveal motion, transforming arcane processing into something tactile. Emergency managers train with astronomers in the same rooms where wildfire and flood are already familiar topics. Small towns near observatories feel invested in the climate of the sky and become fierce defenders of dark, quiet nights. These bonds outlast administrations. They are stitched in stories told at dinner tables, and in the pride of children who visited a dome and touched a bolt that holds the sky in place. International cooperation leaves rhetoric and enters procurement. Contracts are written to avoid supply chain bottlenecks for key detectors and cryocoolers. Standards for alert messages and data formats are agreed to across agencies and nations, then implemented without exception. Satellites share capacity by schedule rather than charity. Coordinated campaigns are penciled in years ahead, with windows reserved for the unexpected, so that when the unexpected arrives, no one must steal time from another mission. A watch that spans a planet must act as if borders are lines on a map, not fences in the sky. Metrics are crafted that measure what matters, not publication counts, not social media attention, intervals between detection and alert, fraction of nights lost to avoidable outages, latency from downlink to public notice, coverage of the sunward blind quarter in hours per week, number of staff cross-trained for 2 critical roles, health of repositories measured by successful restorations, not by terabytes claimed. These numbers are reviewed without drama and acted upon without delay. When a metric drifts, the correction is treated as maintenance, not as scandal. Security is built with the humility that no wall is perfect. Systems assume intrusion will be attempted and possibly achieved. Segmentation confines damage. Simulations red team the pipelines and the instruments. Communication channels carry signatures to prove provenance. The public website shows the next update time even on quiet days, because information vacuums breed invention. When an error slips through, it is corrected quickly with a note that explains the flaw. Trust grows when fallibility is acknowledged and repaired in the light. Environmental stewardship keeps observatories from becoming contradictions. Energy use is minimized by design rather than by afterthought. Solar fields on mountain bases power the servers that process the sky. Water for cooling is recirculated. Waste heat warms nearby facilities where people work. Nighttime lighting honors darkness because the first order of defense is preserving the quality of the canvas itself. Communities see that instruments of vigilance do not borrow against the future to guard the present. Career paths are made wide enough to hold many kinds of talent. Not every contributor is a principal investigator or a coder. Instrument technicians, data librarians, cryo-engineers, projectionists at planetariums, and translators who carry alerts into many languages are recognized as essential in evaluation and pay. The ladder has rungs that value different strengths, and the culture honors the person who keeps a filter clean with the same ceremony that honors a paper that shifts a theory. People remain when their work is seen. Slow money is cultivated as deliberately as slow science. Philanthropic foundations pledge funds that are indexed not to fashion but to obligations. Governments create bond structures that finance new facilities with repayment schedules matched to their scientific lifetimes. Insurance products specifically designed for instruments protect against rare catastrophes. The global public sees an expense categorized not as a discretionary luxury but as a utility, like water and power, because a planet that sees early pays less later. Spares are purchased before they are needed, and they are stored where they can be reached when roads wash out or when a border closes. Documentation includes hand-drawn diagrams for moments when screens go dark. Training includes drills conducted with reduced tools as a musician practices scales without accompaniment. The virtue is not survivalism. It is professionalism that accepts that complexity fails often, and that preparation is kindness to colleagues one has not yet met. Culture is the final instrument, and it is tuned by stories that everyone knows by heart. Tales of near misses in engineering that were caught because someone spoke up despite rank. Tales of quiet nights when nothing extraordinary happened, and yet the pipeline behaved like a song. Tales of teams that disagreed and then converged without humiliation. Tales of communities that supported closed domes during storms and celebrated open domes at dawn. These stories are told to new members until they feel like memory. They are the mnemonic for a civilization that chose to stay awake. All of this assembles into a curtain meant to outlast its makers. It is woven from budgets that do not swing, from training that respects craft, from redundancy that expects accidents and declines to dramatize them, from governance that speaks plainly and listens carefully, from metrics that care about what will save time later, from spares that arrive before the failure they anticipate, from communities that care about night, and from a faith in slow improvement. The curtain is not a wall, it is a practice, renewed each day with quiet deeds that hardly anyone sees. Those deeds are the true architecture of safety. They are the way a species learns to meet a swift universe without haste, eyes open, hands steady, patient enough to greet the next stranger with competence and with grace. Night is a school where attention is taught without speeches. Stars stand at their desks and refuse to move, and in that refusal a lesson emerges about how to keep still while the universe crosses the floor. A small figure in a control room breathes with the slow confidence of a craft learned in hours nobody counts. Screens hum. Plots grow into curves so patient that a heartbeat would seem noisy beside them. A comet from elsewhere writes a faint script across this scene, not to frighten or flatter, but to remind that a world is safest when it is most curious. The watcher and the wanderer hold their distance. Between them stretches a fabric woven from numbers and feeling. Day teaches a different subject. Sunlight spills into kitchens and buses shrug awake, and the attention learned at midnight becomes an attitude toward ordinary life. A city that understands the sky better understands its streets. People look up and then look around with the same steadiness. The practice of tracking a faint point across a crowded star field is not so different from listening carefully to a neighbor. The skill in both cases is to avoid invention and to honor what is truly there. The heart that learns that discipline by night carries it into day as a kind of gentle strength. A planet is a work of balance. Gravity holds oceans in their bowls and air in its invisible shell. Minds add another layer of balance on top of that. They weigh risks against hours, costs against outcomes, fear against the desire to continue as a species worth the continuation. The calculus is never finished. A faint body sliding past the sun at high speed does not trouble that balance so much as reveal it. The revelation is almost kind. It shows that the machinery of vigilance is a mirror. What appears in it is not only a comet's path, but a civilization's posture. Science stands in the middle of this posture, like a lighthouse built from equations. Light curves rise and fall with rotational cadence and whisper about shape. Spectra climb into thin peaks where gas speaks its names. Thermal flux gives diameter a range that can be narrowed by patience. Navigation rules that seem abstract in a classroom become the very bones of action when weeks matter. In these rooms, the equations acquire the warmth of tools, no longer symbols on a board, but wrenches that turn bolts on an engine everyone depends on. The romance lies not in heroics, but in fidelity to method. Engineers enter the frame with hands that smell of acrylic and cold metal. They know the weight of a solar panel and the mood of an actuator that has been trusted to move once after 10 years of not moving. Their discipline folds into the same watchfulness. They do not treat the unexpected as an enemy. They treat it as a load case to be carried with grace. If the opportunity comes to meet a fast traveler with a small craft, the meeting will rest on their habit of testing until failure and documenting until the document reads like a map anyone could follow. Children carry the long arc. They learn that the sky is not a ceiling but a conversation. They are shown a frame where an object 1 billion times older than their school can be measured by their generation, in a language precise enough to move ships and dignified enough to move a mind. They will inherit instruments that can see warm stones near the glare and can measure jets that speak in grams per second. They will inherit tables that say what to do when numbers cross thresholds. The inheritance is not a prophecy. It is a well-stocked shed with a light left on. Culture makes all of this durable. Poems mention perihelion without apology. Films render the quiet confidence of a control room as faithfully as they render a rocket's flame. Local festivals bless dark sky ordinances with a parade of lamps left unlit. The tone is not ominous, it is tender. The tenderness is important. It keeps preparation from freezing into paranoia. It keeps the eyes soft enough to see beauty while they look for danger. It keeps the language of planetary defense from becoming martial. The sky does not attack. It behaves. People decide how they will behave in return. Philosophy leans over the rail and does its work in whispers. Identity stretches. If small bodies wander between stars freely, then any home is porous. Porous does not mean unsafe. It means related. At a scale beyond daily weather and daily politics, matter moves in a grand exchange of dust and ice that touches every system with a trace of its neighbors. To learn this is to feel less alone, not more. The knowledge refuses certainty about destiny and replaces it with solidarity about practice. Be ready, be gentle, be exact, be patient. This is the creed of a watchful world. Even the old giants accept a place in the story as elders rather than as gods. Newton's gravity and Einstein's curvature do not steal scenes. They smile from the back row while instruments and citizens carry the play. Their presence assures that the floor beneath all this action will not give way. A hyperbolic orbit is not a riddle in that company. It is a solved problem with room for nuance. The nuance is where the humanity lives. Which problem to solve first? How to speak the answer without slicing courage into panic. Night returns. It always does. A mountain shakes out its cold. A dome opens with a sigh. A mirror peers into a depth that is not empty, only patient. Somewhere near Sagittarius, a faint point moves. It is not bright. It is not a message in the theatrical sense. It is a shard that has chosen a curve written long ago. The choice for those who watch is simple and hard. Attend, record, share, improve. Do these things as if they were music rather than alarm. Do them with enough care that the next watcher inherits fewer blind spots and more steady routines. Day returns as well. The same species that counted photons stands in a line for bread and takes a child's hand at a crosswalk. The actions inform one another. Patience learned at a telescope becomes patience in a market. Precision learned in a lab becomes clarity in a meeting. A world guarded by a curtain of attention becomes a world safe for small kindnesses. This reciprocity is not mystical. It is practical. Safety at scale protects meaning at scale. Meaning at scale motivates safety. The loop closes and strengthens. A narrator might be tempted to give the last words to fear or triumph. Neither would be honest. The last words belong to continuity. The small light that crossed the sky will fade into the black, and then into the privacy of interstellar cold. The instruments will be cleaned. Schedules will be revised. A committee will rewrite a line in a protocol. A storyteller will find a new metaphor for a jet that turned on for an hour and then slept. This is not anticlimax. It is the precise shape of a life well lived by a planet that has chosen vigilance over spectacle. People already know what to do when attention is demanded by fire or wind. Now they know what to do when attention is demanded by stone and ice. They will learn it again and again until the learning becomes unremarkable. They will not always be thanked for it. They will not always be seen. They will be there, however, in rooms where humidity and time are logged and where the most beautiful noise in the universe is a straight line, becoming straighter as new points arrive. The heart that beats through this work is not loud. It is resolute. The sky remains. It does not conspire for or against. It offers law and room. In that room a civilization has placed an instrument, then another, then 10,000 more, and wrapped them in customs that honor both caution and wonder. Eyes hold the night. Hands hold the day. The planet breathes inside its thin blue shell. Somewhere a child looks up through a window that reflects a kitchen light, and, beyond the reflection, a star. The star holds steady. The child learns what to imitate. Poetic, wind down. Silence gathers on the dark rim of a valley where a telescope cools itself with the calm of stone. The mirror is a lake without wind. It drinks starlight and does not spill. Around it, cables murmur in a language that carries no threat. Only the promise that when a faint ember slides across the field, it will be noticed and signed with a time that will matter later. The notice is not for fear, it is for companionship. To see is to join. Across the dayward side of the planet, sunlight rehearses its old generosity. Leaves use it. Streets shine with it. A nurse stands in a lounge and touches a window with knuckles that remember the night shift and the night sky above the parking lot. In that touch lives the entire education of a species that has decided to keep watch without losing tenderness. The same person who can extract a period from a light curve can calm a frightened patient. The skills feel related because they are. The comet that hurried through will fall back into invisibility and remain perfect there. The perfection has nothing to do with danger or safety. It has to do with the way motion can be honest without apology. A stone keeps its appointment with geometry and leaves a civilization with two gifts. The first is data. The second is mood. The data will tune instruments and budgets. The mood will tune speech and choices. Return to the mountain. Night has begun again. The mirror checks its focus as a pianist checks a chord. The dome turns with a care that would flatter a watchmaker. Somewhere in the rafters, a moth decides to rest. And in that very ordinary decision lives a secret that even equations respect. Life is an attention that lingers. The planet has chosen to linger. The curtain remains lifted. The stage is ready. Sleep then. The sky will not. Cold visitors will pass. Warm hearts will answer. Between them stretches a path that leads from fear to art and from art to practice. Time is the conductor. Light is the score. The performance is quiet and long, and it asks only this: keep looking, keep learning, keep each other. The rest is night, and the night is kind. End of script. Sweet dreams.